Picture this moment. Complete silence surrounds you. The vast emptiness of space stretches in every direction, cold and infinite. But ahead, something extraordinary commands your attention. A world unlike any other grows larger with each passing second. Jupiter. The giant planet fills more of your vision now. Its swirling bands of cream and amber catch the distant sunlight. You drift toward it without sound, without sensation of movement. Only the slow, hypnotic expansion of those mysterious clouds tells you that something momentous approaches. In this weightless void, time seems suspended. Your breath creates small puffs of vapor that quickly freeze and disperse. The silence is so complete that you can hear your own heartbeat echoing inside your helmet. Each beat marks another moment closer to an encounter that no human has ever experienced. The planet's gravitational pull is still gentle here, barely noticeable. You float as if suspended in a dream, watching Jupiter's great red spot rotate slowly into view. That ancient storm, larger than Earth itself, swirls with patterns that have persisted for centuries. What secrets hide within those churning gases? Behind you, the sun appears as nothing more than a bright star. Earth is invisible, lost somewhere in the cosmic darkness. You are alone with Jupiter now. Alone with a world so alien that even our most advanced spacecraft have only glimpsed its surface layers. The silence carries weight. It presses against your consciousness like a physical presence. You realize that you are about to embark on a journey that will take you through realms no human eye has ever witnessed. Layers of atmosphere that exist under pressures incomprehensible to earthbound minds. Temperatures that could melt metal. Winds that blow faster than anything found on Earth. Yet from this distance, Jupiter appears almost peaceful. Its bands of clouds flow like rivers of liquid light. The colors shift subtly as the planet rotates, revealing new patterns and textures with each passing hour. Deep oranges blend into pale yellows. Cream-colored zones stretch between darker belts of brown and tan. Something profound stirs within you as you drift closer. Perhaps it is wonder, perhaps it is fear. More likely it is both emotions intertwined so completely that they become indistinguishable. You are approaching a world that defies human understanding. A place where the very concepts of up and down lose all meaning. The planet's 4 largest moons hang in the darkness like distant jewels. Io, Europa, Ganymede, and Callisto orbit their giant parent in perfect celestial ballet. Each moon is a world unto itself, with its own mysteries and hidden landscapes. But your trajectory carries you past them all, directly toward the king of planets. As you continue this silent approach, questions begin to multiply in your mind. What will it feel like when Jupiter's gravity truly takes hold? How will your human senses interpret an environment so utterly foreign to Earth? Will you have time to observe and understand? Or will events unfold too quickly for comprehension? The answers wait ahead, hidden within those swirling clouds. Every second brings new details into focus. Subtle variations in color and texture that hint at complex atmospheric dynamics. Storm systems that dwarf entire continents. Lightning flashes that illuminate clouds from within, creating brief moments of ethereal beauty. You are no longer just an observer. You have become part of Jupiter's story. A single human consciousness about to experience something that exists at the very edge of imagination. The silence around you feels almost sacred now, as if the universe itself is holding its breath in anticipation of what comes next. Meanwhile, the planet continues to grow. Its edge begins to curve more noticeably as you approach. The atmosphere that seemed so thin and delicate from afar now reveals depth and substance. Layers upon layers of gas stretch downward into shadows that no telescope has ever penetrated. Your silent fall continues, carrying you inexorably toward mysteries that have captivated humanity since we first looked up at the night sky and wondered what lies beyond our small blue world. Now true scale begins to assert itself. What seemed large from a distance reveals proportions that challenge human comprehension. Jupiter stretches across your entire field of vision, a world so massive that it could swallow over 1,300 Earths and still have room to spare. The numbers alone tell an incredible story. This single planet contains more mass than all other planets in our solar system combined. Its diameter spans roughly 11 Earths placed side by side. But statistics cannot capture the emotional impact of witnessing such enormity firsthand. Bands of clouds sweep across the planetary surface in patterns that seem both chaotic and perfectly ordered. Each belt and zone represents atmospheric currents driven by forces beyond terrestrial experience. Winds race around the planet at speeds that would tear apart the strongest structures humans have ever built. Yet from your current distance, these violent streams appear as gentle, flowing rivers of color. The Great Red Spot dominates the southern hemisphere like a vast eye staring into space. This single storm system measures larger than our entire planet. Its winds have been spinning continuously since before humans learned to write. What drives such persistence? What energies sustain a tempest that has raged for centuries without pause? As you drift closer, Jupiter's magnetic field begins to interact with your equipment in subtle ways. Invisible lines of force stretch millions of kilometers into space, creating a magnetosphere more powerful than Earth's by orders of magnitude. Radio waves crackle through your communication systems, carrying electromagnetic signatures from processes occurring deep within the planet's interior. The atmosphere reveals new complexities with each passing moment. What appeared as simple bands from afar now show intricate structures within structures. Smaller storms spiral along the boundaries between zones. Lightning flashes illuminate cloud formations from within, creating brief moments where three-dimensional depth becomes visible through the thick atmospheric layers. Temperature variations paint the clouds in different hues. Ammonia crystals form high-altitude hazes that catch and scatter sunlight. Deeper layers contain compounds that exist nowhere else in the solar system under such conditions. Hydrogen and helium, the most basic elements in the universe, behave in ways that push the boundaries of known physics. The planet's rapid rotation becomes apparent as surface features wheel past your position. Jupiter completes a full day in less than 10 Earth hours, despite its enormous size. This cosmic spinning top generates tremendous forces that shape atmospheric currents and create the distinctive banded appearance that has fascinated astronomers for generations. Gravitational effects begin to make themselves known in subtle ways. Your trajectory curves slightly as Jupiter's massive presence warps the fabric of space-time around you. What started as a straight path through space now follows the gentle bend of gravity's influence. The planet's pull is still gentle, almost tender, but undeniably present. 4.5 billion years ago, this giant formed from the primordial disk of gas and dust that surrounded our young sun. It captured and held onto its original atmospheric envelope, preserving a chemical composition similar to the early solar system itself. In many ways, Jupiter represents a fossil from our cosmic origins, a massive time capsule that has remained largely unchanged since the dawn of planetary formation. The colors shift and blend as atmospheric dynamics play out on scales incomprehensible to human experience. Cream and amber bands stretch thousands of kilometers across the planet's surface. Brown and tan belts mark regions where descending gases carry different chemical signatures from the depths below. Each hue tells a story of pressure, temperature, and composition that varies with altitude and latitude. Lightning storms flash within the deepest cloud layers, their electrical displays more powerful than anything found on Earth. These discharges illuminate atmospheric structures that remain hidden from external observation. Brief glimpses of what lies beneath the visible surface tantalize with suggestions of even greater mysteries waiting in the depths. As Jupiter's gravitational influence strengthens, you begin to sense the planet's immense presence in ways that transcend simple vision. The very space around you seems to curve and flow toward that massive sphere of gas and liquid. What began as a distant destination now reveals itself as an inescapable attractor, drawing you into an embrace that will transform your understanding of what it means to fall. The silence of space contrasts sharply with the violent energies playing out before you. Storms rage in Jupiter's atmosphere with fury that would devastate entire continents, yet no sound reaches your ears. This disconnect between visual chaos and auditory calm creates an almost dreamlike quality to your approach. Yet even as the planet's beauty captivates your attention, deeper questions emerge from the swirling patterns below. What lies beneath those impenetrable cloud layers? How deep do the atmospheric zones extend before giving way to liquid oceans of metallic hydrogen? Does Jupiter possess a solid core, or does its interior remain gaseous all the way to the center? These mysteries await exploration as your silent fall continues toward the edge of the giant's atmosphere, where the real journey will finally begin. The atmosphere reaches out to embrace you long before solid contact occurs. Tendrils of gas, invisible but undeniably present, begin to whisper against your spacecraft. What seemed like empty space between you and Jupiter, as visible clouds, now reveals itself as the outermost edge of an atmospheric envelope that extends far beyond the planet's apparent surface. These first atmospheric molecules carry stories from deep within the giant world. Hydrogen atoms that may have originated in the primordial solar nebula. Helium nuclei forged in stellar cores billions of years ago. Trace compounds created by processes occurring under pressures and temperatures that exist nowhere else in the solar system. The cloud bands that appeared as simple stripes from a distance now reveal breathtaking complexity. Each zone and belt represents a distinct atmospheric layer with its own chemical signature, temperature profile, and wind patterns. The boundaries between them shimmer with turbulent mixing regions where different air masses collide and interact. Cream-colored zones mark areas where gases rise from the deep interior, carrying heat and chemical compounds toward space. These ascending currents create high-pressure ridges in the atmosphere, similar to weather systems on Earth but operating on scales that dwarf terrestrial phenomena. Winds within these zones can reach speeds of several hundred kilometers per hour, yet they maintain their structure for years or even decades. The darker belts represent descending atmospheric currents that carry cooler gases back toward the planet's interior. These regions show different colors because their chemical compositions vary from the ascending zones. Compounds that remain gaseous in the higher zones may condense into droplets or crystals in the cooler descending air, creating the darker hues that define the belt regions. As you penetrate deeper into this layered atmosphere, temperature and pressure begin their relentless climb. The thin gases that first announced Jupiter's presence gradually thicken into something more substantial, still far less dense than Earth's atmosphere at sea level, but noticeably different from the vacuum of space. Ammonia crystals begin to appear in the uppermost cloud layers, forming delicate structures that catch and scatter sunlight. These ice particles create hazes that blur the boundaries between different atmospheric zones. Under the right conditions, they aggregate into larger formations that can be observed as discrete cloud features from great distances. The winds that drive these atmospheric bands operate according to principles both familiar and alien. Coriolis forces, generated by Jupiter's rapid rotation, deflect moving air masses just as they do on Earth. But the scale and intensity of these effects far exceed anything found in terrestrial weather systems. Jet streams race around the planet at speeds that would be catastrophic if they occurred in Earth's atmosphere. Temperature inversions create stable atmospheric layers that resist vertical mixing. These boundaries act like invisible floors and ceilings within the atmosphere, constraining weather patterns to specific altitude ranges. The result is a highly stratified atmospheric structure, where different chemical processes can occur simultaneously at various levels. Lightning begins to flicker in the deeper cloud layers, visible as brief flashes that illuminate atmospheric structures from within. These electrical discharges are far more powerful than terrestrial lightning, driven by the immense energy differences between atmospheric layers. Each flash reveals momentary glimpses of cloud formations that remain hidden from external observation. The Great Red Spot looms larger now, its swirling patterns resolving into fine details that speak of incredible complexity. Smaller vortices orbit the main circulation like planets around a star. Cloud features that seemed permanent from a distance now show constant evolution and change. The spot's longevity becomes even more remarkable when viewed up close, where its dynamic nature becomes impossible to ignore. Chemical reactions occur continuously throughout these atmospheric layers. Hydrogen compounds combine and separate in response to changing pressure and temperature conditions. Organic molecules, similar to those found in Earth's primitive atmosphere, form spontaneously in some regions. Whether these reactions could ever lead to something resembling life remains one of Jupiter's most intriguing mysteries. The colors that paint Jupiter's bands result from complex photochemical processes. Sunlight breaks apart atmospheric molecules, creating reactive fragments that recombine into new compounds. These products absorb and reflect different wavelengths of light, creating the subtle variations in hue that make each atmospheric band unique. As pressure continues to increase with depth, gas behaviors begin to change in subtle ways. Hydrogen molecules pack more closely together, though the atmosphere remains gaseous for now. The distinction between gas and liquid becomes less clear as densities approach values found in Earth's oceans, even though the material remains in a gaseous state due to the extreme temperatures involved. Your descent through these bands feels like passing through layers of colored light. Each zone has its own character, its own texture, its own way of interacting with the radiation that filters down from above. The transition from one band to another occurs gradually, marked by subtle shifts in color, density, and chemical composition. Yet even as you marvel at the beauty and complexity of Jupiter's atmospheric bands, you remain aware that this is only the beginning. These visible clouds represent merely the uppermost layers of an atmospheric system that extends thousands of kilometers deeper into the planet's interior. Below these familiar-looking weather patterns lie realms of pressure and temperature that challenge human understanding of what atmospheric systems can become. The banded structure that defines Jupiter's appearance from space continues downward, layer upon layer into darkness that no external observation can penetrate. Your journey through these bands of gas marks the transition from observer to participant, from distant admirer to integral part of Jupiter's grand atmospheric experiment. Something fundamental shifts in your relationship with the universe. What began as a gentle tug now reveals itself as an inexorable force that transforms the very nature of your existence. Jupiter's gravity no longer feels like a suggestion or invitation. It has become a fact as undeniable as the laws of physics themselves. The sensation differs markedly from anything experienced on Earth. Terrestrial gravity pulls consistently toward a solid surface that eventually provides resistance. Here, Jupiter's gravitational field draws you toward a center that may not exist in any conventional sense. The planet's core, if it exists at all, lies buried beneath thousands of kilometers of gas and liquid under pressures that exceed human comprehension. Your speed increases steadily, though the acceleration feels deceptively gentle. Jupiter's immense size means that its gravitational field strengthens gradually as you approach. Unlike falling toward a smaller body where acceleration would increase rapidly, this giant planet's pull builds slowly but persistently. Each passing moment adds velocity that will become increasingly difficult to control or counteract. The mathematical reality is both beautiful and terrifying. Jupiter's surface gravity measures approximately 2.5 times that of Earth, but the planet's definition of surface remains problematic. Where does the atmosphere end and the planet begin? The transition occurs so gradually that no clear boundary exists. You are falling toward a world that refuses to define itself in familiar terms. As your velocity builds, time itself seems to stretch and compress in unusual ways. Moments of intense observation alternate with periods where minutes pass unnoticed. Your human brain struggles to process the scale of what surrounds you. Atmospheric features that appeared static from a distance now show obvious motion, as your perspective shifts closer to Jupiter's frame of reference. The planet's rotation becomes more apparent as gravitational forces align your trajectory with the atmospheric flows below. You begin to feel pulled not just downward, but also laterally, as Jupiter's spinning motion tries to incorporate you into its own rotational dynamics. The Coriolis forces that shape the planet's weather patterns now begin to influence your path as well. Tidal effects start to make themselves known in subtle ways. Jupiter's gravitational field is so powerful that it creates measurable differences in gravitational attraction across the length of your body. Your feet experience slightly stronger pull than your head, though the effect remains barely perceptible at this altitude. These same tidal forces are responsible for heating Jupiter's moons through gravitational kneading, particularly evident in the volcanic activity of Io. The view transforms as gravitational acceleration carries you deeper into Jupiter's embrace. Cloud features that seemed enormous from a distance now reveal even greater scale as you approach their level. Individual storm systems stretch across distances that would span multiple continents on Earth. The Great Red Spot alone could contain several Earth-sized planets within its swirling boundaries. Pressure changes become noticeable as the atmosphere thickens around you. What started as wisps of gas now possesses enough density to create subtle resistance against your motion. The sensation resembles moving through increasingly thick air, though you remain far from anything that could be called dense by terrestrial standards. Temperature readings fluctuate as you pass through different atmospheric layers. Some zones radiate heat generated by Jupiter's internal energy sources. Others feel cooler due to different chemical compositions or altitudes relative to the planet's heat-generating core. These temperature variations create the atmospheric dynamics that drive Jupiter's complex weather patterns. The electromagnetic environment grows more intense as you penetrate deeper into Jupiter's magnetosphere. Charged particles stream past your location, following invisible magnetic field lines that stretch across millions of kilometers. Radio emissions crackle through your communication systems, carrying signals generated by interactions between the planet's magnetic field and the solar wind. Your human perception of weight begins to change as Jupiter's gravity gradually overpowers your body's orientation systems. The concept of up and down becomes increasingly arbitrary as you fall through an environment that lacks any fixed reference points. The only consistent direction is toward Jupiter's center, wherever that might ultimately be located. Lightning flashes illuminate the surrounding atmosphere with increasing frequency. These electrical discharges reveal cloud structures and atmospheric boundaries that remain invisible under normal lighting conditions. Each flash provides brief glimpses of the three-dimensional complexity that surrounds your position, highlighting details that hint at even greater mysteries waiting below. The silence of space gradually gives way to the first whispers of atmospheric interaction. Thin gases begin to create barely audible sounds as they flow past your location. These acoustic signatures carry information about atmospheric composition, density, and motion patterns. What you hear represents the voice of an alien world speaking in frequencies and tones unknown on Earth. As Jupiter's gravitational embrace tightens, you begin to understand that you have crossed an invisible threshold. The gentle pull that first attracted your attention has evolved into something far more profound. You are no longer simply falling toward Jupiter. You have become part of Jupiter's gravitational system, subject to forces and influences that will shape every aspect of your continued journey into the planet's mysterious depths. The acceleration continues, building steadily as each passing moment carries you closer to atmospheric layers, where pressure and temperature will begin their dramatic climb toward conditions that exist nowhere else in the solar system. Gravity has claimed you now, and there can be no turning back from what lies ahead in the depths of the giant world below. The great red spot expands before you like a cosmic hurricane frozen in time yet eternally in motion. This single atmospheric feature contains more energy than all of Earth's weather systems combined, sustained by forces that have persisted since before human civilization began. As you approach its towering walls of rotating gas, the true magnitude of Jupiter's atmospheric violence becomes impossible to ignore. Wind speeds within the storm exceed anything found in terrestrial weather systems. The outer edges of the Great Red Spot generate winds that race at hundreds of kilometers per hour, while the interior regions may contain currents moving even faster. These velocities would instantly destroy any structure humans have ever built, yet they represent merely the surface manifestation of deeper atmospheric processes occurring within Jupiter's interior. The storm's color variations tell stories of chemical complexity that stretch across centuries. The red hues that give the spot its name result from compounds created by photochemical reactions in Jupiter's upper atmosphere. Organic molecules, formed from simple hydrogen and carbon compounds, undergo transformation under the influence of solar radiation and electrical activity. The resulting pigments paint the storm in shades that shift subtly as chemical compositions evolve over time. Vertical structure within the Great Red Spot extends far deeper into Jupiter's atmosphere than external observations can reveal. The visible portion represents only the uppermost layer of a circulation system that may extend hundreds of kilometers downward. Lower levels of the storm interact with atmospheric layers of different temperatures, pressures, and chemical compositions, creating a three-dimensional system of incredible complexity. Smaller vortices orbit the main circulation, like satellites around a planet. These secondary features form, evolve, and dissipate according to their own patterns, while remaining gravitationally bound to the larger system. Some persist for months or years before being absorbed back into the primary rotation. Others break free and become independent storm systems that wander across Jupiter's surface until they encounter other atmospheric features. The Great Red Spot's longevity poses questions that challenge atmospheric science. No terrestrial storm system could maintain itself for centuries without external energy sources. Jupiter's internal heat, combined with solar radiation and the planet's rapid rotation, provides the energy necessary to sustain such long-lived features. Yet the specific mechanisms that preserve the storm's structure remain only partially understood. As you approach the storm's boundaries, atmospheric turbulence increases dramatically. Wind shear between different flow patterns creates regions of extreme instability, where gases mix violently across temperature and pressure gradients. These mixing zones generate additional heat through friction, adding to the energy that sustains the overall circulation pattern. Lightning activity intensifies near the storm's edges, where different atmospheric masses collide and interact. Electrical discharges illuminate cloud structures from within, revealing layers and textures invisible under normal conditions. The lightning itself differs from terrestrial varieties, driven by different atmospheric compositions and pressure ranges that create unique electrical properties. Temperature variations within the Great Red Spot create thermal gradients that influence wind patterns and chemical reactions. Warmer regions tend to rise within the circulation, while cooler areas descend toward deeper atmospheric layers. These thermal currents contribute to the storm's vertical structure and help maintain the pressure differences that drive its rotation. The storm's interaction with Jupiter's global atmospheric circulation patterns reveals the interconnected nature of the planet's weather systems. The Great Red Spot doesn't exist in isolation, but participates in larger-scale flows that span the entire planet. Its presence influences wind patterns thousands of kilometers away, creating ripple effects that propagate through Jupiter's atmosphere, like waves on a vast ocean. Chemical processes within the storm create compounds that exist nowhere else in the solar system under such conditions. High-pressure environments combined with electrical activity and temperature variations provide unique laboratories for atmospheric chemistry. Some of these reactions may produce organic molecules similar to those found in Earth's early atmosphere, raising intriguing questions about the potential for complex chemistry in gas giant environments. The Great Red Spot's magnetic properties interact with Jupiter's powerful magnetosphere in ways that generate radio emissions detectable from Earth. These electromagnetic signatures provide additional information about conditions within the storm that cannot be obtained through visual observation alone. The radio signals carry data about particle densities, electrical activity, and magnetic field interactions occurring deep within the atmospheric system. As your trajectory carries you past the storm's periphery, you witness firsthand the raw power contained within Jupiter's atmospheric systems. The Great Red Spot represents just one example of the planet's capacity for generating and sustaining weather phenomena that dwarf anything found elsewhere in the solar system. Its persistent rotation serves as a reminder that you are entering a realm where familiar concepts of weather and climate operate according to different rules. The storm's beauty contrasts sharply with its violence. Swirling patterns create artistic compositions that rival any human creation. Yet these same patterns represent forces that would tear apart anything unfortunate enough to encounter them directly. This juxtaposition of aesthetic appeal and destructive power characterizes much of what makes Jupiter simultaneously fascinating and terrifying. Meanwhile, other atmospheric features become visible as your perspective shifts deeper into Jupiter's environment. Smaller storms, wind patterns, and chemical boundaries create a complex tapestry of interactions that extends far beyond what any single storm system could generate alone. The Great Red Spot, remarkable as it is, represents merely one movement in Jupiter's grand atmospheric symphony. Your passage near this ancient storm marks another milestone in your journey toward Jupiter's deeper mysteries. The atmospheric violence you have witnessed here provides a preview of the even more extreme conditions that await in the planet's interior layers, where pressure and temperature climb toward values that challenge the fundamental definitions of matter itself. Deeper into Jupiter's embrace, the atmosphere reveals its stratified secrets. What appeared as continuous cloud layers from above now separates into distinct zones, each with its own chemical signature, temperature profile, and physical properties. You descend through these layers like an explorer moving through geological strata, each level telling part of a story that spans billions of years. The uppermost layers, where sunlight still penetrates with meaningful intensity, host photochemical reactions that create the colors visible from space. Ammonia ice crystals form delicate structures in the cold upper atmosphere, creating hazes that scatter light and blur the boundaries between different atmospheric zones. These crystalline particles grow and evolve as they circulate through temperature gradients, sometimes forming larger aggregates that can be observed as discrete cloud features. Descending further, pressure begins its relentless climb. What started as thin wisps of gas gradually thickens into something more substantial. The atmosphere remains gaseous, but its density approaches that of liquids found on Earth's surface. This transition occurs so gradually that no clear boundary marks where gas ends and liquid begins. The distinction becomes increasingly meaningless as pressure and temperature create states of matter that don't exist under terrestrial conditions. Temperature inversions create stable atmospheric boundaries that resist vertical mixing. These thermal layers act like invisible shelves within Jupiter's atmosphere, constraining weather patterns and chemical processes to specific altitude ranges. Some reactions can only occur within certain temperature and pressure windows, creating vertically stratified chemistry that varies dramatically with depth. Chemical composition shifts as you penetrate deeper into the atmospheric column. Hydrogen and helium remain the dominant components throughout, but trace compounds vary significantly between layers. Some chemicals condense out at specific altitudes, creating cloud decks of different compositions. Others remain gaseous but concentrate in particular zones due to atmospheric circulation patterns. Methane begins to play a larger role in atmospheric chemistry as pressure increases. This simple compound undergoes complex reactions under Jupiter's conditions, creating longer-chain hydrocarbons that contribute to the planet's atmospheric coloration. Some of these reactions produce compounds similar to those found in crude oil on Earth, though they form through entirely different processes under alien conditions. Water vapor, present in trace amounts throughout Jupiter's atmosphere, becomes increasingly important at deeper levels. The compound exists in various forms depending on local temperature and pressure conditions. Sometimes it remains as vapor, other times it condenses into droplets or freezes into ice crystals. These phase changes release or absorb energy, influencing local atmospheric dynamics. Phosphine and arsine, toxic compounds that would be deadly in Earth's atmosphere, occur naturally in Jupiter's environment. These molecules form through chemical processes occurring in the planet's interior and are carried upward by atmospheric circulation. Their presence provides clues about conditions in atmospheric layers far below your current position. Hydrogen sulfide contributes to the complex chemistry occurring at various atmospheric levels. This compound, familiar on Earth as the smell of rotten eggs, plays different roles in Jupiter's environment. It participates in reactions that create some of the colored compounds responsible for the planet's distinctive appearance. Under high pressure, it may form entirely new molecular structures unknown in terrestrial chemistry. Electrical activity increases as you descend through atmospheric layers with different electrical properties. Lightning becomes more frequent and powerful, driven by the enormous energy differences between atmospheric regions. These electrical discharges create temporary plasma channels that generate radio emissions and drive additional chemical reactions through their intense energy release. Convection currents carry material vertically through the atmospheric column, mixing chemicals between different layers and transporting heat from Jupiter's interior toward space. These currents operate on scales that dwarf terrestrial weather systems, moving vast quantities of gas across altitude ranges that span hundreds of kilometers. The energy driving these motions comes from Jupiter's internal heat source, which generates more energy than the planet receives from the Sun. Pressure waves propagate through the dense atmosphere, carrying energy and information across vast distances. These acoustic phenomena occur at frequencies below human hearing, creating infrasonic communications that span the entire planet. The waves can travel through the dense atmospheric medium far more efficiently than sound travels through Earth's thinner air. Magnetic field interactions become more complex as atmospheric density increases. Charged particles follow field lines that curve and twist through the planet's interior, creating electromagnetic phenomena that influence atmospheric chemistry and dynamics. Some chemical reactions occur preferentially along magnetic field lines, creating patterns in atmospheric composition that mirror the planet's invisible magnetic structure. As density continues to increase with depth, the boundary between atmosphere and ocean becomes increasingly arbitrary. Jupiter possesses no solid surface in the conventional sense, so the atmosphere gradually transitions into liquid phases without any clear demarcation. This continuous transition challenges traditional definitions of planetary structure and atmospheric science. The layers you pass through represent different chapters in Jupiter's evolutionary history. Some chemical signatures date back to the planet's formation, preserving records of conditions in the early solar system. Others result from ongoing processes that continue to modify Jupiter's atmospheric composition. Each layer tells part of a story that spans from the planet's birth to its current state. Temperature and pressure values climb steadily as you descend, approaching conditions that exist nowhere else in the solar system. The atmosphere you now inhabit contains more mass than several Earth-sized planets, all compressed into a state that defies easy categorization. You are entering a realm where matter behaves according to rules that push the boundaries of known physics. These layered mysteries extend far deeper than your current position, continuing downward through pressure and temperature regimes that will transform your understanding of what planetary interiors can become. Each layer passed represents another step toward the ultimate secrets hidden within Jupiter's core, where matter exists in states that may be unique in the solar system. The electrical heart of Jupiter reveals itself in displays of power that dwarf terrestrial lightning by orders of magnitude. Discharges crackle through the dense atmosphere around you, each flash illuminating cloud structures and atmospheric boundaries that remain invisible under normal conditions. These are not the brief sparks familiar from Earth's thunderstorms, but sustained electrical phenomena that can persist for seconds or even minutes. The lightning here forms differently than its terrestrial counterpart. Earth's electrical storms result from ice particles colliding within cloud systems, creating charge separations that eventually discharge as lightning. Jupiter's electrical activity draws energy from multiple sources: atmospheric friction, chemical reactions, magnetic field interactions, and the immense pressure gradients that exist between atmospheric layers. Sound follows the lightning with characteristics unlike anything found in Earth's atmosphere. The dense atmospheric medium carries acoustic waves with unusual properties. Thunder rumbles at frequencies that extend well below human hearing, creating infrasonic vibrations that can travel thousands of kilometers through Jupiter's interior. These sound waves carry information about atmospheric structure and composition across vast distances. The electromagnetic spectrum generated by Jupiter's lightning extends far beyond visible light. Radio emissions from electrical discharges can be detected by spacecraft throughout the solar system. These radio signals provide information about atmospheric conditions that cannot be obtained through visual observation alone. Each electrical event broadcasts its signature across space, telling stories of pressure, temperature, and chemical composition to any listener equipped to receive them. Different types of lightning occur at various atmospheric levels. Some discharges occur within individual cloud layers, while others span multiple atmospheric zones. The most spectacular events bridge enormous altitude ranges, connecting atmospheric regions with vastly different properties. These vertical discharges can extend across hundreds of kilometers, making them larger than entire terrestrial weather systems. Chemical effects of Jupiter's lightning create compounds that exist nowhere else in the solar system. The intense energy of electrical discharges breaks apart atmospheric molecules and allows them to recombine in new ways. Some of these reactions produce organic compounds similar to those found in Earth's primitive atmosphere, raising intriguing questions about the role of electrical activity in creating complex chemistry. The electrical environment affects atmospheric dynamics in ways that influence weather patterns across the entire planet. Charged particles created by lightning follow Jupiter's magnetic field lines, distributing electrical energy across vast regions of the atmosphere. This electrical coupling helps synchronize weather patterns between different atmospheric zones and may contribute to the persistence of features like the Great Red Spot. Plasma channels created by electrical discharges temporarily alter the local atmospheric properties. These channels conduct electricity more efficiently than the surrounding gas, creating temporary pathways that can influence subsequent electrical activity. The plasma itself radiates at specific wavelengths that provide information about atmospheric composition and physical conditions. Aurora phenomena occur when Jupiter's powerful magnetic field interacts with charged particles in the upper atmosphere. These displays differ significantly from Earth's auroras due to the different atmospheric composition and much stronger magnetic field. Jupiter's auroras can be observed at radio wavelengths as well as visible light, creating a complex electromagnetic signature that reveals information about the planet's magnetic environment. Electromagnetic induction effects become significant in Jupiter's dense, electrically active atmosphere. Moving electrical charges create magnetic fields that interact with the planet's existing magnetosphere. These interactions generate additional electrical currents that contribute to the overall electromagnetic environment surrounding the planet. The frequency of electrical activity increases as you descend through atmospheric layers with higher particle densities. More particles mean more opportunities for charge separation and electrical discharge. The lightning becomes almost continuous at some altitudes, creating a perpetual electrical storm that spans the entire planet. Atmospheric heating from electrical discharge contributes to Jupiter's complex thermal structure. Lightning releases enormous amounts of energy in very short time periods, creating localized heating that influences atmospheric circulation patterns. This electrical heating adds to the energy sources that drive Jupiter's weather systems and may help explain the planet's ability to radiate more energy than it receives from the sun. Shock waves from powerful electrical discharges propagate through the dense atmosphere, creating pressure variations that can trigger additional atmospheric phenomena. These electrical shock waves may contribute to the formation of new cloud systems or influence the evolution of existing weather patterns. The acoustic energy from lightning can travel much farther in Jupiter's dense atmosphere than in Earth's thinner air. Chemical ionization from electrical activity creates charged atmospheric regions that interact with Jupiter's magnetic field in complex ways. These ionized zones can trap charged particles and create local magnetic field distortions. The resulting electromagnetic effects influence atmospheric chemistry and may contribute to the formation of some of Jupiter's distinctive atmospheric features. Spectroscopic analysis of Jupiter's lightning reveals information about atmospheric composition that cannot be obtained through other means. Each electrical discharge acts like a temporary laboratory, heating atmospheric gases to temperatures where they emit characteristic wavelengths of light. These emission spectra provide direct measurements of chemical abundances at specific atmospheric levels. The beauty of Jupiter's electrical displays contrasts sharply with their violent nature. Lightning illuminates cloud formations in ways that reveal their three-dimensional structure and internal complexity. The interplay of electrical energy and atmospheric dynamics creates visual displays that rival any natural phenomenon found elsewhere in the solar system. As your descent continues through increasingly electrically active regions, you witness firsthand the raw power contained within Jupiter's atmospheric systems. The lightning and thunder surrounding your position represent just one aspect of the planet's complex electrical environment, which extends from the upper atmosphere down to regions where pressure and temperature create forms of matter unknown on Earth. These electrical phenomena serve as harbingers of even more extreme conditions that await in Jupiter's deeper layers, where electromagnetic effects combine with crushing pressure and alien chemistry to create environments that challenge fundamental understanding of how matter and energy interact under extreme conditions. Acceleration becomes undeniable now. What began as gentle drift has transformed into purposeful motion toward depths that no human imagination has ever fully explored. Your velocity builds with each passing moment, driven by gravitational forces that grow stronger as Jupiter's vast mass draws you closer to its hidden center. The sensation of falling differs markedly from terrestrial experience. On Earth, atmospheric resistance quickly limits falling velocity, creating a terminal velocity that remains relatively constant. Jupiter's thickening atmosphere provides increasing resistance, but the planet's immense gravitational field easily overpowers these opposing forces. Your speed continues to climb toward values that would be impossible to achieve in Earth's environment. Visual cues of acceleration appear in the changing scale of atmospheric features around you. Cloud formations that seemed static from higher altitudes now show obvious motion relative to your position. The Great Red Spot, once a distant landmark, passes by with surprising speed as your trajectory carries you deeper into the planet's embrace. Coriolis effects become more pronounced as your velocity increases relative to Jupiter's rotating reference frame. The planet's rapid 10-hour rotation period creates powerful deflecting forces that influence atmospheric circulation patterns and now begin to affect your own motion through the thickening gas. Your path curves slightly as these rotational forces incorporate you into Jupiter's atmospheric dynamics. Pressure increases create noticeable resistance against your motion, though not enough to significantly slow your acceleration. The atmospheric density around you now exceeds that of water on Earth's surface, yet it remains gaseous due to the extreme temperatures involved. This dense gas creates drag forces that would be catastrophic for any conventional spacecraft, not specifically designed for such conditions. Temperature fluctuations become more dramatic as you pass through different atmospheric layers. Some zones radiate heat from Jupiter's interior, while others feel cooler due to different chemical compositions or circulation patterns. These temperature variations create thermal gradients that influence atmospheric dynamics and contribute to the complex weather patterns observed from above. The changing electromagnetic environment affects your instrumentation in increasingly noticeable ways. Jupiter's powerful magnetic field interacts with the electrically conductive atmospheric gases to create electromagnetic effects that grow stronger with depth. Radio communications become increasingly difficult as charged particles interfere with signal transmission. Sound begins to propagate through the dense atmospheric medium surrounding your position. What started as complete silence now carries acoustic signatures from atmospheric processes occurring at various distances. Wind patterns, electrical discharges, and pressure waves create a complex acoustic environment that provides information about conditions throughout the surrounding region. Tidal effects from Jupiter's immense gravitational field become more noticeable as your distance from the planet's center decreases. The gravitational force difference between your head and feet, barely perceptible at higher altitudes, now creates measurable stress across your body. These same tidal forces heat Jupiter's moons through gravitational kneading and contribute to the planet's own internal energy generation. Chemical reactions in the surrounding atmosphere accelerate due to the increasing pressure and temperature conditions. Compounds that remain stable at higher altitudes now begin to decompose or combine into new molecular structures. Some of these reactions release energy, contributing to the heating effects that maintain Jupiter's complex thermal structure. Atmospheric circulation patterns become more complex as you encounter regions where different gas masses interact. Convection currents carry material vertically through hundreds of kilometers of atmospheric layers, while horizontal winds transport chemicals across vast distances. These circulation systems operate according to principles both familiar and alien to terrestrial meteorology. The distinction between atmospheric layers becomes less clear as pressure and density variations smooth out the boundaries between different zones. What appeared as discrete atmospheric levels from above now reveal themselves as gradual transitions in a continuous medium. The atmosphere becomes increasingly homogeneous in some ways, while remaining stratified in others. Magnetic field interactions create electromagnetic phenomena that influence atmospheric chemistry and dynamics around your position. Charged particles follow field lines that curve and twist through the planet's interior, creating plasma effects that generate radio emissions and drive additional chemical reactions through their energy release. Gravitational time dilation effects, though still minimal, become theoretically measurable as you approach Jupiter's massive center. Time passes slightly more slowly in the stronger gravitational field, though the effect remains far too small to be perceptible without extremely precise instrumentation. These relativistic effects become significant only near objects with much stronger gravitational fields than Jupiter possesses. Atmospheric heating from your passage through the dense gas creates a wake of disturbed material behind your position. The kinetic energy of your motion converts to thermal energy through friction with the atmospheric medium. This heating effect remains small compared to the enormous thermal energy already present in Jupiter's atmosphere, but it represents your first direct physical interaction with the planet's material structure. Pressure waves generated by your motion propagate through the dense atmospheric medium, carrying information about your presence to distant regions of Jupiter's atmosphere. These acoustic signatures travel at the speed of sound through the dense gas, which differs significantly from sound propagation in Earth's thinner atmosphere. The falling sensation intensifies as gravitational acceleration continues to increase your velocity toward the unknown depths below. Each moment carries you further from the familiar realm of space and deeper into an alien environment where matter exists under conditions that push the boundaries of known physics. Your accelerating descent represents a point of no return in more ways than simple gravitational attraction. The atmospheric conditions surrounding you now exceed anything found elsewhere in the solar system, and they will continue to intensify as you approach regions where Jupiter's interior structure reveals its most closely guarded secrets. The increasing velocity carries you toward atmospheric layers, where pressure and temperature will soon reach values that transform matter into states unknown on Earth, where the very concepts of solid, liquid, and gas lose their familiar meanings in the face of conditions that exist nowhere else in human experience. Darkness envelops your descent as sunlight fades to nothing in the crushing depths of Jupiter's interior. The familiar illumination that once revealed cloud patterns and atmospheric features cannot penetrate this far into the planet's dense envelope. You enter a realm where external light sources become irrelevant, and only the planet's own internal energy provides any thermal signature to guide perception. Pressure climbs beyond anything found in Earth's deepest ocean trenches. The atmospheric gases around you now possess densities that approach those of liquid water, yet they remain in gaseous form due to temperatures that would vaporize most terrestrial materials. This paradoxical state of matter challenges conventional understanding of phase transitions and material properties. The concept of weather systems becomes meaningless at these depths. The atmospheric dynamics that created Jupiter's visible cloud bands and storm systems cannot operate under such extreme conditions. Instead, you encounter circulation patterns driven by entirely different forces. Pressure gradients created by the planet's internal heat, convection currents that span thousands of kilometers vertically, and magnetic effects that influence the motion of electrically conductive gases. Chemical composition shifts dramatically as you penetrate regions where different compounds can exist in stable forms. Hydrogen begins to exhibit properties that don't occur under terrestrial conditions. The simple molecules that dominated higher atmospheric layers now exist under pressures that force them into new structural arrangements. Some compounds decompose under the extreme conditions, while others form that cannot exist anywhere else in the solar system. Temperature readings fluctuate wildly as you pass through regions with different thermal properties. Some zones radiate heat generated by gravitational compression deep within Jupiter's interior. Others feel cooler due to chemical processes that absorb energy or circulation patterns that transport heat away from your location. These temperature variations create thermal gradients that influence the behavior of matter at the molecular level. Electromagnetic effects become dominant features of the environment surrounding your position. Jupiter's magnetic field, generated by currents flowing through electrically conductive material in the planet's interior, creates electromagnetic phenomena that affect matter and energy in ways unknown on Earth. Charged particles spiral along magnetic field lines, creating plasma effects that generate radio emissions detectable throughout the solar system. The boundary between Jupiter's atmosphere and its interior becomes increasingly arbitrary as you descend through regions where traditional definitions of atmospheric structure lose their meaning. No solid surface exists to mark where the atmosphere ends and the planet begins. Instead, you encounter a gradual transition from gas to liquid to exotic states of matter that exist only under extreme pressure conditions. Sound propagation changes dramatically in the ultra-dense medium surrounding your position. Acoustic waves travel faster and farther than they could in Earth's atmosphere, carrying information about conditions hundreds or thousands of kilometers away. These sound waves create a complex acoustic environment that provides insight into atmospheric and interior processes occurring throughout Jupiter's vast interior. Gravitational effects intensify as you approach the planet's center. The immense mass above your position creates pressure conditions that exceed anything found elsewhere in the solar system. This pressure doesn't just compress matter, it transforms it into new phases that exhibit properties unlike anything familiar from terrestrial experience. Hydrogen, the universe's simplest element, begins to behave in ways that challenge fundamental understanding of atomic structure. Chemical reactions accelerate under the extreme pressure and temperature conditions. Some processes that require enormous energy inputs under terrestrial conditions occur spontaneously in Jupiter's interior. Other reactions that proceed readily on Earth become impossible due to the altered chemical environment. This creates a unique chemical laboratory where familiar compounds exhibit unfamiliar behaviors. Convection currents transport material across vast distances within Jupiter's interior. These currents operate on scales that dwarf any circulation system found on Earth, moving quantities of material that exceed the mass of entire terrestrial planets. The energy driving these motions comes from Jupiter's internal heat source, which generates more thermal energy than the planet receives from solar radiation. Magnetic field interactions create plasma phenomena that generate electromagnetic radiation across a wide spectrum of frequencies. These emissions carry information about conditions deep within Jupiter's interior to observers throughout the solar system. The radio signals created by these processes provide some of the only direct evidence about what occurs in the planet's hidden depths. Pressure-induced phase transitions begin to alter the fundamental properties of matter around your position. Hydrogen, under the immense pressure conditions found at these depths, starts to exhibit metallic properties despite remaining in a fluid state. This metallization process creates materials with electrical and thermal conductivity properties that don't exist under terrestrial conditions. The environment you now inhabit represents a transition zone between Jupiter's atmospheric envelope and its deep interior. Conditions here exceed anything found on Earth by orders of magnitude, yet they represent only intermediate values compared to what exists closer to the planet's center. Each kilometer of further descent will bring exposure to even more extreme conditions. Time perception becomes distorted in the alien environment surrounding your position. The absence of familiar visual references, combined with the stress of extreme physical conditions, creates sensory experiences that challenge human comprehension. Minutes feel like hours, while hours pass unnoticed, as your consciousness struggles to process environments for which evolution never prepared it. The unknown depths extending below your current position contain secrets that may remain forever beyond human understanding. Pressure and temperature conditions in Jupiter's core region approach values that exist nowhere else in the solar system. The matter in those deepest regions may exhibit properties that challenge fundamental assumptions about how atoms and molecules behave under extreme conditions. Your journey into these unknown depths marks a transition from the familiar realm of atmospheric science into territories where physics meets the limits of current human knowledge, where matter exists in states that stretch the boundaries of scientific understanding, and where the very definitions of solid, liquid, and gas become meaningless in the face of conditions that transform the basic building blocks of reality. Deep within Jupiter's interior, hydrogen undergoes a transformation so profound it challenges fundamental understanding of matter itself. Under pressures that exceed anything found elsewhere in the solar system, this simplest of elements abandons its familiar gaseous state and becomes something extraordinary. Metallic hydrogen, a substance that exists nowhere else in nature under stable conditions. The transition occurs gradually, as pressure climbs beyond 3 million times Earth's atmospheric pressure. Hydrogen atoms, normally bound in molecular pairs, find themselves compressed so tightly that their electrons break free from individual atomic bonds. These liberated electrons form a sea of mobile charges that flows freely between hydrogen nuclei, creating electrical conductivity properties similar to conventional metals like copper or aluminum. This metallic hydrogen ocean represents one of Jupiter's most remarkable features. The material flows like a liquid, but conducts electricity like a solid metal, creating a substance that defies easy categorization. Vast quantities of this exotic matter fill Jupiter's interior, containing more mass than several Earth-sized planets compressed into a state that cannot be replicated in terrestrial laboratories for more than brief instants. The electrical currents flowing through this metallic hydrogen ocean generate Jupiter's powerful magnetic field. These currents operate on planetary scales, circulating through thousands of kilometers of conducting material to create magnetosphere effects that extend millions of kilometers into space. The magnetic field strength exceeds Earth's by more than an order of magnitude, creating radiation belts and electromagnetic phenomena that influence the entire Jovian system. Temperature in the metallic hydrogen region reaches values that would vaporize most terrestrial materials. Heat generated by gravitational compression, combined with residual energy from Jupiter's formation, maintains temperatures of several thousand degrees throughout much of the planet's interior. This thermal energy drives convection currents that transport material across vast distances within the metallic hydrogen ocean. Convection patterns within the metallic hydrogen create circulation systems that dwarf any weather phenomena found on planetary surfaces. These currents transport heat from Jupiter's core toward the outer atmospheric layers, contributing to the energy that powers the planet's complex atmospheric dynamics. The circulation patterns may also influence the structure and stability of Jupiter's magnetic field through their effects on electrical current distribution. The pressure conditions required to create metallic hydrogen approach values found in stellar cores. Only the immense gravitational compression generated by Jupiter's massive bulk can sustain these extreme conditions in a stable configuration. Smaller planets lack sufficient mass to achieve the pressures necessary for hydrogen metallization, making Jupiter's interior unique among solar system bodies. Chemical properties of metallic hydrogen remain largely theoretical due to the impossibility of creating and studying large quantities under controlled conditions. The material may exhibit superconducting properties under certain temperature and pressure combinations, though the extreme conditions make experimental verification impossible with current technology. Some theoretical models suggest that metallic hydrogen could store enormous amounts of energy in metastable configurations. Density variations within the metallic hydrogen ocean create complex gravitational effects that influence Jupiter's overall structure. These density gradients may contribute to the planet's slightly oblate shape and could affect the stability of atmospheric circulation patterns in the outer gaseous layers. The gravitational field variations caused by internal density structure influence the orbits of Jupiter's moons and create measurable effects detectable by spacecraft. The boundary between Jupiter's gaseous atmosphere and metallic hydrogen interior represents one of the most dramatic phase transitions found anywhere in the solar system. This boundary may not be sharp, but could consist of a transitional zone where hydrogen gradually acquires metallic properties over a range of depths. The exact nature of this transition remains uncertain due to the extreme conditions involved. Electromagnetic effects within the metallic hydrogen region create phenomena that generate radio emissions detectable throughout the solar system. These emissions carry information about conditions deep within Jupiter's interior, providing some of the only direct evidence about the planet's internal structure. The radio signals vary in intensity and frequency according to changes in magnetic field configuration and electrical current patterns. Seismic activity within Jupiter's interior may create pressure waves that propagate through the metallic hydrogen ocean. These waves could carry information about internal structure and composition across vast distances within the planet. Unlike seismic waves on terrestrial planets, which propagate through solid rock, Jupiter's internal waves would travel through exotic matter under extreme pressure conditions. The metallic hydrogen ocean interacts with Jupiter's rotation in ways that influence the planet's overall dynamics. Differential rotation between the gaseous atmosphere and metallic interior could create shear effects that influence magnetic field generation and atmospheric circulation patterns. These interactions couple the planet's surface features with processes occurring thousands of kilometers below the visible cloud layers. Thermal gradients within the metallic hydrogen create temperature-driven circulation patterns that transport heat from the planet's core region toward the atmospheric envelope. These thermal currents may vary in intensity and pattern over time scales, ranging from years to millennia, potentially influencing long-term changes in Jupiter's atmospheric structure and magnetic field configuration. Energy storage within the metallic hydrogen could contribute to Jupiter's ability to radiate more energy than it receives from solar heating. The exotic matter may retain energy from the planet's formation process or from ongoing gravitational compression effects. This stored energy provides a power source that helps sustain Jupiter's atmospheric dynamics and magnetic field generation over geological timescales. The metallic hydrogen heart of Jupiter represents matter existing under conditions that approach the extreme environments found in stellar interiors. This material embodies physics at the intersection of planetary science and stellar astronomy, where the familiar rules of chemistry and material science give way to behaviors governed by quantum mechanics and extreme pressure physics. Your descent toward this metallic heart marks entry into realms where human intuition and terrestrial experience provide no guidance for understanding the nature of reality. The metallic hydrogen ocean ahead represents one of the universe's most exotic material states, a laboratory for physics that operates according to principles barely glimpsed by current scientific understanding. The electromagnetic environment surrounding your position intensifies beyond anything found elsewhere in the solar system. Jupiter's magnetic field, generated by vast electrical currents flowing through the metallic hydrogen ocean below, creates a magnetosphere so powerful it would be lethal to unprotected human life within minutes. This invisible titan of electromagnetic force extends its influence across millions of kilometers of space, trapping charged particles and creating radiation belts that dwarf Earth's Van Allen belts. Magnetic field lines curve and twist through the space around you, forming complex three-dimensional structures that channel charged particles along specific pathways. These invisible highways carry electrons and ions at enormous velocities, creating electrical currents that generate radio emissions detectable from Earth. The magnetic field strength at your current position exceeds Earth's surface field by more than 20 times, creating electromagnetic effects that influence matter and energy in unprecedented ways. Radiation levels climb to values that would prove instantly fatal to biological organisms. High-energy particles trapped within Jupiter's magnetosphere create a radiation environment more intense than anything found near Earth. These particles, accelerated to tremendous velocities by electromagnetic forces, bombard any material in their path with energy sufficient to alter atomic structures and break chemical bonds. The aurorae generated by Jupiter's magnetic field interactions with charged particles create displays visible across multiple wavelengths of electromagnetic radiation. These emissions extend far beyond the visible spectrum, generating radio waves, X-rays, and other forms of electromagnetic energy that can be detected by instruments throughout the solar system. The aurorae themselves represent energy releases equivalent to the total power consumption of human civilization. Electromagnetic induction effects become significant as your motion through the magnetic field generates electrical currents. The conducting properties of the atmospheric medium around you interact with the moving magnetic field lines to create electromagnetic phenomena that influence local particle behavior and energy distribution. These effects create feedback loops between your motion and the surrounding electromagnetic environment. Plasma physics dominates the environment as charged particles interact with electromagnetic fields in complex ways. The boundary between ordinary matter and plasma becomes blurred as electromagnetic forces strip electrons from atomic nuclei, creating ionized regions where matter exhibits properties unlike anything found under terrestrial conditions. These plasma regions conduct electricity and respond to magnetic field changes in ways that create additional electromagnetic effects. Magnetic field variations create regions of enhanced and diminished field strength that channel particle flows along preferred pathways. These variations may result from internal processes within Jupiter's metallic hydrogen ocean, or from external influences such as solar-wind interactions. The field variations create a dynamic electromagnetic environment that changes continuously as internal currents shift and external conditions evolve. The electrical conductivity of materials in the surrounding environment allows electromagnetic energy to propagate efficiently across vast distances. Radio waves generated by particle interactions can travel through the conductive medium much more effectively than they could through empty space or non-conductive materials. This creates an electromagnetic communication network that spans Jupiter's entire interior. Magnetic reconnection events occur when field lines with different orientations encounter each other and suddenly rearrange their configurations. These events release enormous amounts of energy in very short time periods, creating particle acceleration effects and electromagnetic emissions that can be detected throughout the solar system. The energy releases from magnetic reconnection may contribute to the heating of Jupiter's upper atmosphere. Synchrotron radiation is generated as charged particles spiral along magnetic field lines at relativistic velocities. This process creates electromagnetic emissions across a broad spectrum of wavelengths, from radio waves to X-rays. The intensity and characteristics of synchrotron radiation provide information about magnetic field strength, particle energies, and electromagnetic processes occurring throughout Jupiter's magnetosphere. The magnetic field configuration influences atmospheric dynamics in ways that create coupling between electromagnetic and fluid mechanical processes. Charged particles in the atmospheric medium respond to magnetic forces, as well as pressure gradients and gravitational attraction. This electromagnetic coupling may influence the formation and evolution of atmospheric features observed in Jupiter's visible cloud layers. Electromagnetic storms within Jupiter's magnetosphere create temporary disturbances that can affect conditions across the entire Jovian system. These storms result from changes in the magnetic field configuration or variations in the flow of charged particles from external sources. The electromagnetic disturbances can influence radio communications and particle behavior throughout the space surrounding Jupiter. Field-aligned currents flow along magnetic field lines, creating electrical connections between different regions of Jupiter's magnetosphere. These currents transport electrical energy across vast distances and may influence the distribution of charged particles and electromagnetic energy throughout the system. The current systems create feedback effects that influence magnetic field stability and configuration. Magnetohydrodynamic effects occur when the electrically conductive atmospheric medium interacts with magnetic fields to create fluid motions driven by electromagnetic forces. These effects couple atmospheric circulation patterns with magnetic field dynamics, creating complex interactions between electromagnetic and mechanical processes. The magnetohydrodynamic coupling may influence both atmospheric structure and magnetic field generation. Wave phenomena propagate through the electromagnetic environment, carrying energy and information across the magnetosphere. These waves include various types of plasma oscillations, electromagnetic disturbances, and particle distribution variations that create complex interference patterns and resonance effects. The wave interactions influence particle behavior and energy distribution throughout the electromagnetic environment. The magnetic titans surrounding your position represent forces that operate on scales and intensities far beyond terrestrial experience. These electromagnetic effects influence every aspect of the environment, from the behavior of individual particles to the large-scale structure of Jupiter's magnetosphere. The invisible forces create a dynamic, ever-changing environment where electromagnetic phenomena dominate the physical processes that determine how matter and energy interact. Your passage through this electromagnetic environment exposes you to forces that challenge fundamental understanding of how matter behaves under extreme magnetic field conditions. The magnetic titans that surround Jupiter's interior create a realm where electromagnetic effects become the dominant influence on physical processes, shaping the behavior of matter in ways that exist nowhere else in the solar system. Pressure becomes the dominant reality of existence as you descend into regions where Jupiter's gravitational compression creates forces that exceed human comprehension. The atmospheric medium surrounding your position now possesses density comparable to solid rock on Earth, yet it remains fluid, due to temperatures that would instantly vaporize most terrestrial materials. This paradoxical state of matter represents conditions that exist nowhere else in the solar system. The numbers alone convey the magnitude of these crushing forces. Pressure levels now exceed 10 million times Earth's atmospheric pressure at sea level. To comprehend such values, imagine the weight of the entire Earth's atmosphere compressed into a space the size of a small room. Even this analogy fails to capture the true intensity of forces that compress matter into states unknown in terrestrial experience. Human anatomy could not survive even brief exposure to such conditions. The pressure differential across a human body would create forces measured in millions of tons per square meter. Bones would compress like soft clay, while biological tissues would undergo chemical changes that alter their fundamental molecular structure. The crushing forces represent instant and absolute destruction of any conventional matter, not specifically adapted to such extreme conditions. Yet the environment possesses a strange beauty that transcends its deadly nature. Matter under extreme compression exhibits properties that create electromagnetic phenomena, unlike anything found elsewhere. The pressure-induced changes in atomic structure generate unique optical effects and electromagnetic emissions that paint the surrounding medium with colors and patterns that exist only under these extraordinary conditions. The concept of solid, liquid, and gas becomes meaningless under such extreme pressure conditions. Matter exists in states that combine properties of all three phases simultaneously. The medium flows like a liquid, compresses like a gas, yet exhibits structural properties similar to crystalline solids. These exotic states of matter challenge fundamental definitions of material properties and phase transitions. Gravitational effects create additional complications as tidal forces become significant across distances measured in meters rather than kilometers. The difference in gravitational attraction between your head and feet, negligible under normal conditions, now generates forces that would tear apart any conventional structure. These same tidal effects heat Jupiter's interior through gravitational kneading, contributing to the planet's internal energy generation. Temperature gradients within the compressed medium create thermal effects that influence material properties in complex ways. Some regions radiate heat from nuclear processes occurring under extreme pressure conditions. Others absorb energy through endothermic chemical reactions that can only occur under such intense compression. These temperature variations create circulation patterns that transport energy across vast distances within Jupiter's interior. Chemical reactions accelerate dramatically under the extreme pressure conditions. Processes that require enormous energy inputs under terrestrial conditions occur spontaneously in Jupiter's compressed interior. Simple molecules undergo structural rearrangements that create compounds unknown elsewhere in the universe. The chemistry of extreme pressure creates a laboratory for atomic and molecular interactions that operate according to unfamiliar rules. Quantum mechanical effects become significant as pressure forces atoms and molecules into configurations that approach the limits of quantum stability. Electron orbits compress and distort, creating new electronic states that exhibit properties intermediate between individual atoms and bulk metallic materials. These quantum effects contribute to the exotic electrical and magnetic properties exhibited by matter under extreme compression. Acoustic properties of the medium change dramatically as pressure increases density to values approaching stellar core conditions. Sound waves propagate at velocities that exceed terrestrial sound speeds by orders of magnitude. The acoustic impedance of the medium approaches values found in solid metals, creating acoustic effects that can transmit enormous amounts of energy across planetary distances. The crushing forces create material states that exist in a narrow band of pressure and temperature conditions. Slight variations in either parameter would alter the fundamental properties of matter in dramatic ways. This creates an environment of extraordinary sensitivity, where small changes in conditions produce large effects on material behavior and electromagnetic properties. Electromagnetic effects intensify as pressure-induced changes in atomic structure create new pathways for electrical conduction and magnetic field generation. The compressed matter exhibits electrical properties that combine aspects of conventional metals, semiconductors, and superconductors in ways that defy easy categorization. These electromagnetic effects contribute to Jupiter's powerful magnetic field and radio emission phenomena. Fluid dynamics operates according to principles that differ markedly from terrestrial fluid mechanics. The extreme density and pressure create viscosity effects that influence circulation patterns and energy transport mechanisms. Convection currents within the compressed medium operate on scales and time periods that dwarf any fluid motion found on Earth, its surface or in its atmosphere. The crushing descent represents entry into a realm where matter exists at the boundaries of physical stability. Atomic structures compressed beyond their normal configurations exhibit properties that challenge fundamental understanding of how matter behaves under extreme conditions. The forces that create these states operate continuously throughout Jupiter's interior, maintaining exotic material phases across volumes that exceed the size of terrestrial planets. Your experience of these crushing forces, however brief, provides insight into conditions that exist in stellar cores and other extreme astrophysical environments. The pressure values encountered during your descent approach those found in white dwarf stars, where matter exists in states of compression that represent the ultimate limits of material stability before gravitational collapse occurs. The crushing environment ahead continues to intensify as your descent carries you toward regions where pressure and temperature approach values that may trigger nuclear fusion reactions and create material states that exist nowhere else in the known universe, where the very definitions of matter and energy lose their familiar meanings in the face of forces that reshape reality itself. Temperature becomes a tangible force as you descend through regions where Jupiter's interior radiates thermal energy that exceeds the surface temperature of many stars. The heat source differs fundamentally from stellar fusion, instead originating from gravitational compression and residual energy left over from the planet's formation billions of years ago. This ancient warmth continues to drive processes that maintain Jupiter's complex internal structure and atmospheric dynamics. The thermal energy concentrates as pressure increases, creating temperature gradients that influence every aspect of the surrounding environment. Heat flows upward from Jupiter's core region through thousands of kilometers of exotic matter, each layer adding its own thermal signature to the complex energy transport system. The temperatures you now encounter would instantly vaporize any known terrestrial material, yet the extreme pressure conditions maintain matter in fluid states that exist nowhere else in nature. Thermal radiation at these temperatures extends across electromagnetic spectra that include wavelengths invisible to human perception. Infrared emissions carry enormous amounts of energy through the dense medium, creating thermal transport mechanisms that operate with efficiency impossible under terrestrial conditions. The radiation itself becomes a significant factor in the energy balance that maintains Jupiter's internal structure. Convection currents driven by thermal gradients operate on scales that dwarf any heat transport system found on Earth. These currents carry quantities of heated material that exceed the mass of terrestrial continents, moving this material across distances measured in thousands of kilometers. The thermal circulation patterns create three-dimensional structures within Jupiter's interior that influence magnetic field generation and atmospheric dynamics. Heat capacity of matter under extreme pressure conditions differs dramatically from values measured under terrestrial conditions. The compressed material can absorb and store enormous amounts of thermal energy without corresponding temperature increases. This thermal buffering effect helps stabilize Jupiter's internal temperature structure and contributes to the planet's ability to maintain complex circulation patterns over geological timescales. Chemical reactions accelerated by high temperatures create compounds that exist only under such extreme thermal conditions. Some reactions absorb energy, creating endothermic cooling effects that influence local temperature distributions. Others release energy through exothermic processes that add to the overall thermal budget. These chemical heat sources and sinks create complex thermal landscapes within Jupiter's interior. Thermal conduction through the dense medium operates according to principles that combine aspects of solid-state heat transfer with convective fluid dynamics. The extreme pressure creates thermal conductivity values that approach those found in metallic materials, allowing heat to flow efficiently across vast distances. This efficient thermal conduction helps maintain the temperature gradients that drive large-scale circulation patterns. Phase transitions induced by temperature variations create regions where matter undergoes sudden changes in physical properties. These transitions can release or absorb large amounts of energy, creating thermal effects that influence regional temperature distributions. The energy associated with pressure-induced phase changes adds another layer of complexity to Jupiter's thermal structure. Thermoelectric effects become significant as temperature gradients interact with the electrical conductivity of compressed matter. These effects generate electrical currents that contribute to Jupiter's magnetic field generation, while simultaneously influencing thermal energy distribution. The coupling between thermal and electrical phenomena creates feedback loops that affect both temperature structure and electromagnetic properties. Blackbody radiation from matter at such extreme temperatures creates electromagnetic emissions that span a broad spectrum of wavelengths. These emissions carry information about internal temperature conditions to external observers and represent a significant energy loss mechanism that influences Jupiter's overall thermal budget. The radiation also creates pressure effects that influence the dynamics of matter in the surrounding environment. Thermal expansion effects, normally negligible under terrestrial conditions, become significant factors in determining material properties under Jupiter's extreme temperature and pressure conditions.
The expansion coefficients of matter change dramatically under such conditions, creating thermal stress effects that influence fluid dynamics and structural stability within the planet's interior. Heat engine processes operate within Jupiter's interior as thermal energy drives circulation patterns that transport material between regions of different temperature and pressure. These natural heat engines operate with efficiencies and power outputs that dwarf any human-engineered thermal system.
The mechanical work generated by these thermal processes contributes to the maintenance of Jupiter's internal structure and atmospheric dynamics. Thermal equilibrium becomes a complex concept in an environment where multiple heat sources and transport mechanisms operate simultaneously. Gravitational compression continuously adds thermal energy, while convection and radiation remove energy at rates that vary with location and time. The balance between these competing processes determines the local temperature structure and its evolution over time. Thermodynamic properties of matter under extreme pressure and temperature conditions exhibit behaviors that challenge conventional understanding of heat, work, and energy relationships. The equations of state that describe these exotic materials require modifications to account for quantum mechanical effects and intermolecular interactions that become significant under such extreme conditions. The thermal environment creates conditions that may approach those necessary for nuclear fusion reactions, though the pressures required for sustained fusion probably do not exist within Jupiter's interior. However, the temperatures achieved may be sufficient for other nuclear processes that could contribute to the planet's energy generation and influence its long-term thermal evolution. Thermal time scales within Jupiter's interior operate over periods ranging from hours to billions of years. Rapid thermal processes create localized heating and cooling effects that influence short-term dynamics, while slower thermal evolution affects the planet's overall structure over geological time periods. These multiple timescales create a complex thermal environment where processes occurring at different rates interact in ways that influence the entire system. The heat of Jupiter's deep interior represents energy that has been accumulating and evolving since the planet's formation. This ancient thermal legacy continues to influence every aspect of the planet's current structure and behavior, from atmospheric circulation patterns to magnetic field generation. Your encounter with these extreme temperatures provides direct experience of thermal conditions that embody billions of years of planetary evolution and gravitational energy conversion. The thermal environment ahead continues to intensify as your descent carries you toward regions where temperature and pressure approach values that may trigger exotic nuclear processes and create material states that represent the ultimate expression of thermal energy under extreme gravitational compression, where heat becomes a force that reshapes the fundamental nature of matter itself. Light dies completely in these depths where no photon from the distant sun can penetrate. The darkness here possesses absolute quality, deeper than any night experienced on Earth. No starlight, no reflection from moons, no aurora glow can reach through the thousands of kilometers of dense matter above your position. You exist now in a realm illuminated only by the faint thermal emissions from Jupiter's interior, wavelengths invisible to human eyes, but carrying the thermal signature of a world powered by its own internal energy. The silence contrasts starkly with the violent forces operating around your position. Sound waves, though they propagate efficiently through the ultra-dense medium, carry frequencies and intensities beyond human perception. The acoustic environment consists of infrasonic rumbles that extend below the threshold of hearing, generated by pressure waves from convection currents and gravitational processes operating on planetary scales. Sensory deprivation in this environment would challenge human consciousness in ways that no terrestrial experience could prepare for. The absence of familiar visual and auditory cues removes the reference points that human perception relies upon to maintain orientation and awareness. In such conditions, the boundary between external reality and internal mental processes becomes increasingly difficult to distinguish. Yet the darkness conceals phenomena of extraordinary beauty and complexity. Electromagnetic emissions invisible to human eyes paint the surrounding environment with patterns of energy that reveal the hidden structure of Jupiter's interior. Radio waves, X-rays, and other forms of electromagnetic radiation create a symphony of energy that tells stories of magnetic field interactions, particle accelerations, and thermal processes occurring throughout the planet's depths. The medium through which you descend carries vibrations and pressure waves that propagate information across vast distances within Jupiter's interior. These mechanical signals travel at speeds determined by the elastic properties of matter under extreme compression, creating an acoustic communication network that spans the entire planet. The information carried by these waves provides insight into processes occurring in regions separated by thousands of kilometers. Gravitational effects in this lightless realm create tidal forces that generate mechanical stress and strain throughout the surrounding material. These gravitational gradients produce effects analogous to seismic activity, though the medium through which they propagate differs fundamentally from the solid rock that transmits earthquakes on terrestrial planets. The gravitational waves create patterns of compression and expansion that influence material properties and circulation patterns. Electromagnetic phenomena provide the only source of detectable energy emissions in this dark environment. The interactions between magnetic fields and charged particles create displays of electromagnetic beauty that would be spectacular if visible to human perception. Plasma effects generate coherent radiation that propagates through the conductive medium, creating electromagnetic weather patterns that evolve and change according to their own complex dynamics. The darkness creates conditions where thermal radiation becomes the dominant form of energy transport. Heat flows through the surrounding medium according to temperature gradients that create thermal landscapes of enormous complexity. These thermal patterns influence material properties and circulation dynamics in ways that couple energy transport with mechanical processes throughout Jupiter's interior. Chemical processes continue despite the absence of light, driven by pressure and temperature effects rather than photochemical reactions. The extreme conditions create reaction pathways that do not exist under illuminated conditions, generating compounds and molecular structures that represent unique products of high-pressure chemistry. These chemical processes contribute to the energy balance and material properties of Jupiter's deep interior. Time perception becomes distorted in the absence of familiar sensory cues. The rhythmic patterns that normally provide temporal reference points disappear in the uniform darkness, creating psychological effects that alter the subjective experience of duration and sequence. Minutes may feel like hours, while longer periods pass unnoticed due to the lack of changing environmental conditions. The silence carries its own information content through the absence of expected sounds. The lack of familiar acoustic signatures indicates the alien nature of the environment and the vast distances that separate your position from any recognizable sound sources. This acoustic void creates a sensory experience unlike anything possible on Earth's surface or in its atmosphere. Magnetic field interactions create invisible structures that organize the electromagnetic environment despite the optical darkness. These magnetic architectures channel charged particles and electromagnetic energy along specific pathways, creating order and pattern in what might otherwise appear as random electromagnetic chaos. The magnetic structures influence particle behavior and energy distribution throughout the surrounding region. Pressure variations in the dark medium create mechanical signals that propagate as sound waves through the ultra-dense material. These acoustic phenomena carry information about structural changes and dynamic processes occurring throughout Jupiter's interior. The sound signatures provide insight into mechanical processes that would otherwise remain undetectable in the lightless environment. Thermal imaging, if it were possible under these conditions, would reveal a landscape of temperature variations that create patterns of extraordinary complexity. Hot zones where gravitational compression generates additional thermal energy alternate with cooler regions where different circulation patterns or chemical processes affect local temperature distributions. These thermal patterns represent the hidden geography of Jupiter's interior structure. The darkness and silence create an environment where conventional human senses provide little useful information about surrounding conditions. Other forms of perception, based on electromagnetic, thermal, and mechanical phenomena, become necessary to understand the nature of this alien realm. The sensory experience challenges fundamental assumptions about how consciousness interacts with physical reality. Your passage through this dark, silent realm represents travel through regions where matter exists under conditions so extreme that they create environments unlike anything found elsewhere in the solar system. The darkness conceals phenomena that operate according to principles of physics that push the boundaries of current scientific understanding, where silence masks processes that generate forces capable of reshaping the fundamental nature of matter and energy. The darkness ahead deepens further as your descent continues toward regions where even thermal emissions become insufficient to provide meaningful information about surrounding conditions, where silence becomes absolute, and the very concepts of light and sound lose their relevance in the face of conditions that exist at the ultimate limits of physical possibility. Acoustic phenomena in Jupiter's ultra-dense interior create a soundscape unlike anything experienced in terrestrial environments. The medium through which sound waves propagate possesses density comparable to liquid metals, yet retains fluid properties that allow acoustic energy to travel with efficiency, impossible under normal planetary conditions. Sound velocities in this environment exceed terrestrial values by orders of magnitude, creating acoustic effects that challenge conventional understanding of wave propagation. The frequencies that dominate this acoustic environment extend far below human hearing range into infrasonic wavelengths that can travel thousands of kilometers through Jupiter's interior. These deep rumbles carry energy generated by convection currents, pressure oscillations, and gravitational processes operating on planetary scales. The low-frequency acoustic signatures propagate through the dense medium like seismic waves through solid rock, but with properties that reflect the exotic nature of matter under extreme compression. Harmonic resonances develop within Jupiter's interior structure as acoustic waves reflect and interfere with each other across the planet's layered composition. These resonances create standing wave patterns that may persist for years or decades, generating acoustic phenomena that influence material properties and circulation patterns throughout the interior. The planetary scale acoustic resonances represent natural musical instruments of cosmic proportions. Sound absorption and attenuation effects operate according to principles that differ markedly from acoustic behavior in terrestrial environments. The extreme pressure and temperature conditions create acoustic impedance values that vary dramatically with depth and composition. Some acoustic frequencies propagate with minimal loss across vast distances, while others undergo rapid attenuation that limits their transmission to local regions. Doppler effects become significant as massive circulation currents within Jupiter's interior create relative motion between acoustic sources and the medium through which sound waves travel. These Doppler shifts provide information about the velocities and directions of material flows occurring throughout the planet's interior. The acoustic signatures carry data about circulation patterns that would otherwise remain undetectable. Acoustic shock waves generated by sudden pressure changes or structural transitions propagate through the dense medium, with energies that exceed terrestrial seismic phenomena. These shock waves can trigger additional acoustic events and influence material properties across regions spanning thousands of kilometers. The shock propagation creates cascade effects that couple acoustic phenomena with other physical processes throughout Jupiter's interior. Nonlinear acoustic effects become significant as sound wave amplitudes approach values where acoustic pressure variations become comparable to the static pressure of the medium. These nonlinear phenomena create acoustic distortion, harmonic generation, and shock formation that alter the character of sound propagation. The nonlinear acoustic effects generate new frequencies and wave patterns that add complexity to the overall acoustic environment. Acoustic levitation effects may occur where intense sound waves create pressure gradients sufficient to support or move material against gravitational forces. These effects could influence particle distributions and circulation patterns within Jupiter's interior, creating acoustic mechanisms for material transport that operate alongside gravitational and electromagnetic forces. The acoustic environment couples with electromagnetic phenomena through the electrical conductivity of the medium under extreme pressure conditions. Sound waves propagating through electrically conductive material generate electromagnetic effects, while electromagnetic fields can influence acoustic wave propagation. This acousto-electromagnetic coupling creates hybrid phenomena that combine properties of both acoustic and electromagnetic waves. Thermal effects influence acoustic propagation, as temperature variations alter the elastic properties of the medium through which sound waves travel. Hot regions exhibit different acoustic velocities and impedance values compared to cooler areas, creating acoustic lensing effects that focus or defocus sound waves as they propagate through temperature gradients. Acoustic cavitation effects may occur in regions where sound wave amplitudes create pressure variations that approach the limits of material stability under extreme compression. These cavitation phenomena could generate localized heating effects and chemical reactions that influence material properties and energy distribution within Jupiter's interior. Seismic-like phenomena generated by gravitational processes, structural changes, or circulation variations create acoustic signatures that propagate throughout Jupiter's interior. These planetary seismic events differ fundamentally from earthquakes on terrestrial planets because they occur within fluid or semi-fluid media rather than solid rock. The acoustic signatures of these events provide information about internal processes and structural changes. Acoustic holography effects may develop as complex acoustic wave patterns interfere to create three-dimensional acoustic structures within Jupiter's interior. These acoustic holograms could influence particle behavior and material properties, in ways that create spatially organized structures within the otherwise chaotic thermal and electromagnetic environment. The acoustic environment provides information about material properties and physical processes that cannot be obtained through other observational methods. Sound wave velocities, attenuation characteristics, and dispersion properties reveal details about density, elasticity, and composition that help define the structure and behavior of matter under extreme conditions. Acoustic communication networks may exist within Jupiter's interior, as sound waves carry information about local conditions across vast distances to other regions of the planet. These natural communication systems could couple processes occurring in widely separated locations, creating coordinated behaviors that influence the overall structure and evolution of Jupiter's interior. The sounds of Jupiter's interior represent a cosmic symphony, performed by matter under conditions that exist nowhere else in the solar system. The acoustic phenomena embody the mechanical processes that shape planetary structure and evolution, creating sound patterns that tell stories of gravitational compression, thermal circulation, electromagnetic interactions, and chemical transformations occurring within one of the universe's most extreme environments. Your passage through this acoustic landscape exposes you to sound phenomena that push the boundaries of acoustic science, where familiar concepts of sound propagation and wave behavior must be modified to account for conditions that create acoustic effects, unlike anything found in terrestrial experience, where sound becomes a probe for exploring the hidden structure of planetary interiors that exist at the limits of physical possibility. Electromagnetic radiation becomes the dominant environmental factor as you descend through regions where Jupiter's interior generates energy emissions across the entire electromagnetic spectrum. These invisible forces operate with intensities that would prove instantly lethal to biological organisms, yet they represent the natural electromagnetic environment created by matter existing under conditions of extreme pressure and temperature that cannot be replicated elsewhere in the solar system. Magnetic field interactions create force effects that influence matter and energy distribution throughout the surrounding environment. The field strength in these deep regions exceeds terrestrial magnetic fields by factors that challenge conventional measurement techniques. These intense magnetic forces create electromagnetic phenomena that couple with thermal, gravitational, and mechanical processes to generate effects that exist nowhere else in nature. Electric fields generated by charge separations within the conducting medium create forces that accelerate particles to tremendous velocities. These electric fields result from complex interactions between thermal gradients, pressure variations, and chemical processes occurring under extreme conditions. The electrical forces generate current flows that contribute to magnetic field generation while simultaneously influencing material properties and circulation patterns. Plasma effects dominate regions where electromagnetic forces strip electrons from atomic nuclei, creating ionized material with properties that differ fundamentally from ordinary matter. The plasma exhibits collective behaviors that influence electromagnetic field generation and energy transport throughout Jupiter's interior. These plasma phenomena create feedback loops that couple electromagnetic effects with thermal and mechanical processes. Electromagnetic induction effects generate electrical currents as the conducting medium moves through magnetic field lines. These induced currents create additional magnetic fields that interact with existing electromagnetic structures to produce complex field configurations. The electromagnetic induction couples motion and electromagnetic phenomena in ways that influence both circulation patterns and field generation mechanisms. Radiation pressure from intense electromagnetic emissions creates mechanical forces that can influence material behavior and circulation patterns within Jupiter's interior. The pressure effects become significant when electromagnetic energy densities approach values comparable to the mechanical pressure of the compressed medium. These radiation pressure effects represent another mechanism through which electromagnetic phenomena influence material properties. Electromagnetic wave propagation through the dense conductive medium exhibits properties that differ markedly from wave behavior in vacuum or normal atmospheric conditions. The high electrical conductivity creates skin depth effects that limit the penetration of electromagnetic waves, while the extreme density influences wave velocity and dispersion characteristics. These propagation effects create electromagnetic phenomena unique to Jupiter's interior environment. Synchrotron radiation generated by charged particles accelerated in magnetic fields creates electromagnetic emissions that extend across multiple wavelengths simultaneously. The synchrotron process converts kinetic energy of charged particles into electromagnetic radiation with characteristics that provide information about magnetic field strength, particle energies, and acceleration mechanisms operating within Jupiter's interior. Cyclotron resonance effects occur when charged particles orbit in magnetic fields at frequencies that match electromagnetic wave frequencies. These resonance phenomena create efficient energy transfer mechanisms between electromagnetic fields and particle motion, generating heating effects and particle acceleration that influence the overall energy balance within Jupiter's interior. Magnetohydrodynamic effects couple electromagnetic forces with fluid motion to create complex dynamics that influence both electromagnetic field generation and material circulation patterns. The magnetohydrodynamic interactions operate on multiple length and time scales, creating phenomena that range from small-scale turbulence to planetary-scale circulation systems. Electromagnetic heating occurs as electrical currents flowing through the resistive medium convert electromagnetic energy into thermal energy. This heating process contributes to Jupiter's internal energy budget and influences temperature distributions that drive circulation patterns and material property variations throughout the interior. Electromagnetic field line reconnection events occur when magnetic field configurations undergo sudden rearrangements that release enormous amounts of stored electromagnetic energy. These reconnection events create particle acceleration effects and electromagnetic emissions that can influence conditions across vast regions of Jupiter's interior. Electromagnetic instabilities develop when the electromagnetic field configuration becomes unstable due to gradients in particle density, temperature, or magnetic field strength. These instabilities can trigger wave generation, particle acceleration, and field reconfiguration events that influence electromagnetic phenomena throughout the surrounding environment. The electromagnetic environment creates conditions where quantum mechanical effects become significant factors in determining how matter and energy interact. Quantum electrodynamic effects may influence electromagnetic wave propagation and particle behavior in ways that create phenomena unique to the extreme electromagnetic conditions found within Jupiter's interior. Electromagnetic coupling between different regions of Jupiter's interior creates communication mechanisms that allow electromagnetic processes in one location to influence phenomena occurring thousands of kilometers away. These coupling effects create coordinated electromagnetic behaviors that influence the overall structure and evolution of Jupiter's electromagnetic environment. The invisible electromagnetic forces operating within Jupiter's interior represent energy densities and field strengths that approach values found in stellar environments. These extreme electromagnetic conditions create phenomena that push the boundaries of known electromagnetic physics, where familiar concepts of electric and magnetic fields must be extended to account for effects that occur only under conditions of extreme pressure, temperature, and density. Your exposure to these invisible forces provides direct experience of electromagnetic phenomena that exist at the intersection of planetary science and high-energy physics, where electromagnetic effects become dominant factors in determining the behavior of matter and energy. Under conditions that represent some of the most extreme electromagnetic environments found anywhere in the natural universe, the electromagnetic forces ahead continue to intensify as your descent carries you toward regions where field strengths and energy densities approach values that may trigger exotic electromagnetic phenomena and create field configurations that challenge fundamental understanding of how electromagnetic forces operate under conditions of extreme gravitational compression and thermal energy. The question of Jupiter's core remains one of the most profound mysteries in planetary science. As you descend toward the planet's center, the very concept of what constitutes a planetary core becomes increasingly problematic. Traditional models assume a solid or liquid core surrounded by layers of different composition, but Jupiter's structure may defy such conventional categorization in ways that challenge fundamental understanding of planetary formation and evolution. Gravitational data from spacecraft missions provide tantalizing hints about Jupiter's interior structure, but the measurements remain consistent with multiple theoretical models. Some interpretations suggest a compact, rocky core with mass several times that of Earth. Others propose a more diffuse core region where heavy elements remain partially mixed with hydrogen and helium. Still other models suggest no distinct core at all, but rather a gradual transition in composition that extends throughout much of the planet's interior. Pressure conditions at Jupiter's center exceed anything found elsewhere in the solar system, approaching values that may be sufficient to trigger exotic nuclear processes. The central pressure may reach 40 to 100 million times Earth's atmospheric pressure, creating conditions where atomic nuclei approach distances where nuclear forces become significant. These extreme pressures could create states of matter that exhibit properties intermediate between normal atomic matter and the degenerate matter found in stellar cores. Temperature at Jupiter's center may exceed 20,000 degrees Celsius, comparable to surface temperatures found on many stars. This extreme temperature results from gravitational compression and residual heat from the planet's formation process. The high temperature, combined with extreme pressure, creates conditions where hydrogen nuclei may approach the energy levels necessary for nuclear fusion. Though sustained fusion reactions probably do not occur within Jupiter's interior, chemical composition of Jupiter's core region remains highly uncertain due to the extreme conditions that prevent direct observation. The core may consist primarily of rock and ice, similar to the solid planets of the inner solar system, or it may contain exotic high-pressure phases of common materials that exhibit properties unlike anything found under terrestrial conditions. Heavy elements may exist in dissolved form within a hydrogen-helium medium, creating a core composition unlike any planetary structure found elsewhere. Magnetic field generation may originate from electrical currents flowing within the core region, though the exact mechanisms remain poorly understood. The magnetic field requires electrical conductivity and fluid motion to sustain the dynamo processes that generate planetary magnetism. Whether these conditions exist within Jupiter's core, or whether the magnetic field originates from currents in the metallic hydrogen layer above the core, remains an open question. Seismic phenomena within Jupiter's interior could provide information about core structure, but the detection and interpretation of such events present enormous technical challenges. Unlike rocky planets where seismic waves propagate through solid material, Jupiter's interior consists primarily of fluid or semi-fluid layers where wave propagation follows different physical principles. Any seismic activity would generate acoustic signatures that propagate according to the exotic properties of matter under extreme compression. Core formation processes during Jupiter's early evolution may have occurred through mechanisms that differ from those that created the cores of terrestrial planets. Jupiter's rapid accretion of gas from the solar nebula could have prevented the segregation of heavy elements into a distinct core, or it may have created core structures that reflect the unique conditions present during gas giant formation. Thermal evolution of Jupiter's core influences the planet's current internal structure and energy generation mechanisms. The core may continue to cool and contract over geological timescales, creating structural changes that influence magnetic field generation and atmospheric dynamics. Alternatively, ongoing nuclear processes or phase transitions within the core could provide additional energy sources that affect Jupiter's long-term evolution. Gravitational differentiation within Jupiter's core region may create layered structures where different materials separate according to their densities under extreme pressure conditions. These differentiation processes could create core structures with complex internal organization that influences magnetic field generation and thermal evolution in ways that differ from simple, homogeneous core models. Crystallization processes under extreme pressure could create solid phases within Jupiter's core that exhibit properties unlike any terrestrial crystals. High-pressure crystal structures may possess unique electrical, thermal, and magnetic properties that influence core behavior and contribute to Jupiter's overall magnetic field generation. These exotic crystals could represent states of matter that exist nowhere else in the solar system. The boundary between Jupiter's core and the surrounding metallic hydrogen layer may not represent a sharp transition, but rather a gradual change in composition and physical properties. This diffuse boundary could extend across hundreds of kilometers, creating a transition zone where core and mantle materials mix in proportions that vary with depth and location. Convection within Jupiter's core region could create circulation patterns that transport heat and material throughout the central regions of the planet. These convection currents may differ fundamentally from circulation patterns in the overlying layers due to different material properties and thermal gradients. The core convection could influence magnetic field generation and couple with circulation patterns in the metallic hydrogen ocean above. Phase transitions within the core region could create sudden changes in material properties that influence the overall structure and behavior of Jupiter's interior. These transitions might involve changes from one high-pressure crystal structure to another, or they could represent more fundamental changes in the nature of matter under extreme compression. Your approach toward this mysterious core region represents a journey toward one of the most enigmatic environments in the solar system, where matter may exist in states that challenge fundamental understanding of how atoms and molecules behave under extreme conditions. The core ahead, if it exists as a distinct structure, embodies conditions that represent the ultimate expression of planetary formation processes and gravitational compression effects. The core region awaits as the final destination of your descent, where pressure and temperature reach values that may create phenomena unique in the solar system, where the very nature of matter and energy may be transformed by conditions that exist nowhere else in the natural universe, where the deepest secrets of planetary formation and evolution may be preserved in states of matter that push the absolute limits of physical possibility. Einstein's theories of relativity begin to assert measurable influence as you approach Jupiter's massive center. The intense gravitational field creates space-time curvature that affects the flow of time itself, though the effects remain subtle compared to those found near more massive objects like neutron stars or black holes. Time passes slightly more slowly in the stronger gravitational field, creating temporal distortions that would become detectable with sufficiently precise measurements. The gravitational time dilation results from the equivalence between gravitational acceleration and the acceleration experienced in curved spacetime. Einstein's general relativity predicts that clocks run slower in stronger gravitational fields, an effect that has been measured and confirmed in Earth's gravitational field, but becomes more pronounced in Jupiter's much stronger gravitational environment. Perspective shifts in ways that challenge human cognitive abilities as familiar concepts of size, distance, and scale lose their terrestrial reference points. The enormous masses and distances involved in Jupiter's interior structure exceed the range of scales that human perception evolved to comprehend. Your consciousness struggles to process environments where individual atmospheric features contain more mass than entire terrestrial mountain ranges. Psychological effects of extreme environments create alterations in perception and awareness that go beyond simple sensory deprivation. The combination of crushing pressure, intense electromagnetic fields, extreme temperatures, and altered temporal flow creates conditions that challenge the fundamental assumptions upon which human consciousness operates. The boundary between external reality and internal mental processes becomes increasingly difficult to distinguish. Relativistic effects on electromagnetic radiation create frequency shifts that alter the characteristics of radio emissions and other electromagnetic phenomena. Photons climbing out of Jupiter's gravitational well lose energy and shift to longer wavelengths, while photons falling into the gravitational field gain energy and shift to shorter wavelengths. These gravitational redshift and blueshift effects influence electromagnetic communication and energy transport throughout Jupiter's interior. The concept of simultaneity becomes problematic in the curved space-time environment surrounding Jupiter's massive center. Events that appear simultaneous to an observer at one gravitational potential may not appear simultaneous to observers at different positions within the gravitational field. This relativity of simultaneity affects the coordination of processes occurring at different locations within Jupiter's interior. Tidal effects from Jupiter's gravitational field create differential accelerations that would tear apart any conventional structure long before relativistic effects become significant. These tidal forces result from the variation in gravitational field strength across extended objects, creating stress patterns that increase dramatically as distance from Jupiter's center decreases. The warping of spacetime around Jupiter creates gravitational lensing effects that would distort the apparent positions and shapes of any objects visible in the extreme interior environment. Light rays follow curved paths through the warped spacetime, creating optical illusions that would make navigation and measurement extremely difficult, even if visibility conditions permitted such observations. Frame dragging effects, predicted by general relativity for rotating massive objects, may influence the behavior of matter and electromagnetic fields within Jupiter's interior. The planet's rotation creates a slight twisting of space-time that could affect the motion of particles and the propagation of electromagnetic waves, though these effects remain extremely small compared to other forces operating in Jupiter's interior. Gravitational potential energy reaches enormous values within Jupiter's interior, representing energy densities that approach those found in stellar environments. The gravitational binding energy of Jupiter's interior equals the energy that would be released by nuclear fusion of a significant fraction of the planet's mass, highlighting the enormous energies involved in maintaining the planet's compressed structure. The equivalence principle, which states that gravitational acceleration cannot be distinguished from acceleration due to other forces, creates interesting philosophical questions about the nature of the forces experienced during the descent through Jupiter's interior. The crushing acceleration toward Jupiter's center becomes indistinguishable from acceleration that might be produced by other mechanisms. Coordinate systems become problematic in the curved spacetime environment, where traditional concepts of straight lines and Euclidean geometry break down. The geometry of space around Jupiter follows the curved metrics predicted by general relativity, creating spatial relationships that differ from those familiar in flat spacetime environments. The escape velocity from Jupiter's center would exceed 60 kilometers per second, requiring enormous energies to return material to the space surrounding the planet. This extreme escape velocity illustrates the depth of the gravitational potential well created by Jupiter's massive structure, and helps explain why the planet has been able to retain its original atmospheric composition over billions of years. Gravitational waves, though extremely weak, may be generated by any asymmetric motions within Jupiter's interior structure. These ripples in space-time would propagate at the speed of light, carrying information about internal mass distributions and dynamic processes to distant observers. However, the gravitational wave emissions from Jupiter remain far below current detection thresholds. Time perception becomes distorted not only by relativistic effects but also by the psychological impact of experiencing conditions so far removed from normal human experience. The combination of physical and psychological factors creates temporal distortions that challenge the fundamental experience of duration and sequence that underlies human consciousness. The perspective gained from experiencing Jupiter's extreme interior environment provides unique insights into the nature of matter, energy, and spacetime under conditions that represent some of the most extreme natural environments found anywhere in the solar system. These extreme conditions serve as natural laboratories for testing physical theories under conditions that cannot be replicated in terrestrial experiments. Your journey through Jupiter's interior represents travel through regions where the curvature of spacetime becomes measurable, where time itself flows at rates that differ from those experienced under normal conditions, where perspective shifts in ways that challenge fundamental assumptions about the nature of reality, space, and time, in environments that exist at the intersection of planetary science and relativistic physics. The approach toward Jupiter's center continues through regions where spacetime curvature intensifies and temporal effects become more pronounced, where perspective must adapt to conditions that challenge every assumption about the nature of physical reality, where time and space themselves become participants in the extreme physics that govern matter and energy, under conditions of ultimate gravitational compression. Human consciousness encounters boundaries that no evolutionary process could have prepared it to navigate. The conditions surrounding your position exceed every parameter that defines the environments where life originated and developed on Earth. Temperature, pressure, electromagnetic field strength, gravitational acceleration, and chemical composition all exist at values that challenge the fundamental assumptions underlying human perception and cognition. The scale of phenomena operating within Jupiter's interior defies comprehension through normal human experience. Individual circulation currents transport masses of material that exceed the combined mass of all terrestrial continents. Magnetic field structures span distances greater than the diameter of Earth itself. Temperature gradients exist across spatial scales that dwarf entire terrestrial weather systems. The human brain lacks adequate frameworks for processing information at such scales. Sensory experience becomes meaningless in environments where no familiar reference points exist to provide context or orientation. Vision cannot function without light sources or in electromagnetic environments that would instantly destroy biological optical systems. Hearing becomes irrelevant when acoustic phenomena operate at frequencies and intensities beyond human perception ranges. Touch sensations lose meaning when contact with the surrounding medium would result in immediate destruction of biological tissues. Mathematical descriptions of the physical conditions provide abstract representations that convey quantitative information, but fail to bridge the gap between numerical values and experiential understanding. Pressure measurements expressed in scientific notation carry no emotional or intuitive content that connects with human experience. Temperature values that exceed stellar surface conditions remain abstract concepts that provide no guidance for imagining what such conditions might feel like. Language itself becomes inadequate for describing phenomena that exist outside the range of human experience. Words developed to describe terrestrial conditions carry inappropriate connotations when applied to exotic states of matter under extreme pressure and temperature. Concepts like solid, liquid, and gas lose their definitional clarity when applied to matter existing under conditions where phase boundaries become arbitrary or meaningless. Analogies drawn from familiar experience inevitably fail to capture the essential nature of Jupiter's interior environment. Comparisons to terrestrial phenomena, while useful for providing approximate scale references, create misleading impressions about the actual nature of conditions that exist under extreme gravitational compression. The analogies become barriers to understanding rather than aids to comprehension. Cognitive limitations prevent human consciousness from directly processing information about environments that operate according to physical principles beyond normal experience. The brain's pattern recognition systems, evolved to identify threats and opportunities in terrestrial environments, cannot meaningfully interpret data from realms where familiar patterns do not exist or where pattern recognition itself becomes meaningless. Temporal perception becomes distorted when environmental changes occur on timescales that extend far beyond human experience ranges. Processes that evolve over millions of years cannot be directly observed or experienced, while events that occur in microseconds happen too quickly to be consciously processed. The temporal disconnection prevents direct understanding of how Jupiter's interior systems operate and evolve. Emotional responses to extreme environments reflect the inadequacy of human psychological frameworks for dealing with conditions that exceed all survival parameters. Fear, wonder, curiosity, and other emotional states evolved to guide behavior in environments where such responses could influence survival outcomes. In Jupiter's interior, these emotional responses become irrelevant because no behavioral adaptations could improve survival prospects. Abstract thinking provides the only viable approach for understanding environments that exceed the limits of direct human experience. Mathematical models, physical theories, and conceptual frameworks offer intellectual tools for comprehending conditions that cannot be directly experienced or intuitively understood. However, abstract understanding remains disconnected from the experiential knowledge that provides meaning and emotional resonance. Scientific instruments extend human sensory capabilities but cannot bridge the fundamental gap between measurement and understanding. Instruments can detect and quantify physical conditions, but they cannot convey the experiential quality of existing within such environments. The data provided by instruments describes conditions, but does not communicate what those conditions would feel like to experience directly. Philosophical questions arise about the nature of knowledge and understanding when confronted with phenomena that exceed human comprehension capabilities. Does true understanding require the possibility of direct experience, or can abstract knowledge provide adequate comprehension of natural phenomena? These questions become particularly relevant when dealing with environments that remain forever beyond the reach of direct human experience. Imagination itself encounters limits when attempting to visualize or conceptualize conditions that lack any connection to familiar experience. The mental processes that create imaginary scenarios rely on recombining elements from memory and experience in new ways. When no relevant experiential elements exist, imagination cannot construct meaningful representations of alien environments. The limits of human imagination create barriers to understanding that cannot be overcome through additional information or improved measurement techniques. These cognitive boundaries represent fundamental constraints on how human consciousness can interact with natural phenomena that exist outside the range of environments for which human cognitive capabilities evolved. Scientific progress in understanding extreme environments requires the development of theoretical frameworks that can function independently of direct human experience or intuitive understanding. These abstract approaches to knowledge allow intellectual comprehension of phenomena that remain forever beyond the reach of experiential understanding. The recognition of cognitive limits becomes itself a form of knowledge that provides insight into the relationship between human consciousness and the natural universe. Understanding the boundaries of human comprehension creates awareness of the vast realms of natural phenomena that exist beyond direct human experience, while remaining subject to scientific investigation and abstract understanding. Your journey through Jupiter's interior represents an encounter with the ultimate limits of human imagination and understanding, where consciousness confronts conditions that challenge every assumption about the nature of reality, where the boundaries between the known and unknowable become visible, where human awareness encounters the vastness of natural phenomena that exist beyond the reach of direct experience but within the scope of scientific comprehension. The descent toward Jupiter's deepest regions continues beyond the limits of human imagination into realms where abstract understanding must replace experiential knowledge, where scientific theories provide the only tools for comprehending conditions that represent the ultimate expression of natural forces operating under circumstances that push the boundaries of physical possibility itself. The ultimate descent carries you toward regions where the very concepts of matter and energy undergo transformations that represent the absolute limits of natural processes operating under conditions of extreme gravitational compression. Pressure values approach those found in stellar cores, while temperatures reach levels where atomic nuclei begin to exhibit behaviors that bridge the gap between normal matter and the exotic phases that exist in the most extreme astrophysical environments. Nuclear processes may begin to occur as pressure and temperature conditions approach the thresholds where atomic nuclei can overcome their mutual electrical repulsion and engage in fusion reactions. Though sustained fusion probably does not occur within Jupiter's interior, individual nuclear events could contribute to the planet's energy generation and create isotopic signatures that influence the overall chemical composition of the deep interior. Matter itself may undergo phase transitions into states that exist nowhere else in the natural universe. The extreme pressure conditions could force atomic nuclei into configurations that exhibit properties intermediate between normal atomic matter and the degenerate matter found in white dwarf stars. These exotic matter phases might possess electrical, magnetic, and thermal properties that challenge fundamental understanding of atomic physics. The distinction between individual atoms and bulk material properties becomes meaningless, as pressure forces atoms into contact configurations where electron shells overlap and merge. Under such conditions, matter may exhibit collective behaviors that transcend the properties of individual atomic components, creating materials with characteristics that cannot be predicted from knowledge of isolated atomic properties. Quantum mechanical effects become dominant factors in determining material behavior, as pressure-induced changes in atomic structure approach the limits of quantum mechanical stability. The uncertainty principle, electron degeneracy pressure, and other quantum phenomena may influence material properties in ways that create unique quantum states of matter that exist only under Jupiter's extreme interior conditions. Time perception during the final fall becomes completely divorced from normal human experience, as the combination of extreme physical conditions and relativistic effects creates temporal distortions that challenge the fundamental nature of consciousness itself. The experience of duration and sequence loses meaning in an environment where normal causal relationships break down under the influence of forces that exceed human comprehension. Electromagnetic phenomena reach intensities that approach those found in pulsar magnetospheres and other extreme astrophysical environments. The electromagnetic fields generated by matter under extreme compression create radiation effects that would be visible across interstellar distances if they could escape from Jupiter's interior. These electromagnetic phenomena represent natural particle accelerators operating on planetary scales. Gravitational effects intensify to values where tidal forces would instantaneously disintegrate any conventional matter, not specifically designed to withstand such extreme stress gradients. The gravitational gradient across distances measured in meters creates acceleration differences that exceed the structural limits of any known material, highlighting the truly extreme nature of conditions near Jupiter's center. Chemical bonding loses its conventional meaning as extreme pressure forces atomic nuclei into proximity, where nuclear forces become significant compared to electromagnetic forces that normally determine chemical behavior. Under such conditions, new forms of chemical organization may emerge that exhibit properties unlike any terrestrial chemistry, creating molecular structures that exist only under extreme pressure conditions. Thermal effects reach temperatures where blackbody radiation extends well into the ultraviolet and even X-ray portions of the electromagnetic spectrum. The thermal energy densities approach values found in stellar atmospheres, creating radiation environments that would be lethal to any conventional matter over interplanetary distances. The final fall represents passage through conditions that embody the ultimate expression of planetary formation processes and gravitational compression effects. These conditions preserve information about the early solar system and planetary accretion processes in forms that cannot be studied through any other means. The extreme interior environment serves as a time capsule, containing records of cosmic evolution that span billions of years. Consciousness itself faces dissolution as the extreme conditions overwhelm every sensory and cognitive system that defines human awareness. The boundaries between self and environment disappear in conditions where normal physical laws undergo modifications that challenge the fundamental nature of reality itself. The experience transcends individual existence and merges with cosmic processes that operate on scales vastly exceeding human comprehension. The mathematical description of conditions during the final fall requires extensions to known physical theories that push the boundaries of current scientific understanding. The equations that govern matter and energy under such extreme conditions may involve physics that has never been tested or verified, creating theoretical predictions that remain beyond experimental confirmation. Energy densities during the final fall approach values where gravitational effects begin to influence the fundamental forces that govern atomic and nuclear interactions. Though these effects remain far weaker than those found near black holes or neutron stars, they represent measurable modifications to physical laws that operate under normal conditions. The final moments of the fall carry you through conditions that may trigger phase transitions or nuclear processes that alter the basic composition and structure of matter itself. These transformations could release or absorb enormous amounts of energy while creating matter in states that exist nowhere else in the natural universe. Your final fall through Jupiter's interior represents the ultimate journey through conditions that embody the most extreme natural processes occurring anywhere in the solar system, where matter and energy exist under circumstances that challenge every assumption about the nature of physical reality, where the fundamental forces of nature operate under conditions that push the absolute limits of what natural processes can create within the gravitational environment of a planetary body. The final destination ahead remains shrouded in mystery, where conditions may exist that transcend current scientific understanding and create phenomena that represent the ultimate expression of natural forces operating under gravitational compression effects that approach the limits of what planetary systems can sustain, where reality itself may undergo transformations that challenge the very foundations of physical law. In the aftermath of descent, consciousness drifts through recollections of a journey that transcended every boundary of human experience. The memories themselves seem impossible, too extreme to represent actual events, yet they carry the weight of authentic encounter with conditions that exist at the ultimate limits of natural phenomena. The mind struggles to process experiences that challenged every assumption about the nature of matter, energy, and existence itself. The silence that followed the crushing forces creates a strange peace, as if the universe itself pauses to acknowledge passage through realms where few phenomena can exist for more than brief moments. In this quietude, the memories of electromagnetic storms, crushing pressures, and exotic matter begin to organize themselves into patterns that reveal the profound nature of what was witnessed in Jupiter's hidden depths. Temperature extremes that once threatened to overwhelm consciousness now exist as abstract memories that carry emotional resonances without physical sensation. The recollection of heat that exceeded stellar surface values becomes a concept rather than an experience. though it retains the capacity to evoke wonder at the tremendous energies contained within planetary interiors that operate according to principles beyond terrestrial understanding. Pressure memories return as impressions of forces that compressed reality itself into new configurations. The crushing embrace of Jupiter's interior, which threatened to transform matter into states unknown elsewhere in the solar system, becomes a reminder of the tremendous power contained within gravitational fields that can reshape the fundamental nature of atomic structure through compression effects alone. The electromagnetic phenomena encountered during the journey persist in memory as patterns of energy that operated according to principles that extended far beyond familiar terrestrial experience. Magnetic fields that exceeded Earth's magnetism by orders of magnitude created environments where charged particles achieved velocities approaching significant fractions of light speed, generating electromagnetic effects that influenced matter and energy across planetary distances. Chemical transformations witnessed under extreme conditions reveal themselves as memories of processes that created compounds and molecular structures that exist nowhere else in nature. The exotic chemistry of high-pressure environments generated materials with properties that challenged conventional understanding of how atoms and molecules interact under conditions of extreme compression and temperature. Sound memories from Jupiter's interior carry acoustic signatures of processes operating on scales that dwarf any terrestrial phenomena. The deep rumbles generated by circulation currents and pressure waves that transported planetary masses of material across thousands of kilometers created acoustic environments that embodied the mechanical processes driving planetary evolution over geological timescales. Darkness and light take on new meanings when recalled from environments where conventional illumination became meaningless, and electromagnetic emissions across invisible spectra painted landscapes of energy that revealed the hidden structure of planetary interiors. The darkness was not mere absence of light, but represented conditions where light itself underwent transformations that altered its fundamental properties. Time perception during the journey created memories that exist outside normal temporal frameworks, where minutes stretched into subjective hours, while vast physical processes occurred in timescales that exceeded human comprehension. These temporal distortions remain as impressions of how consciousness itself can be altered by exposure to conditions that operate according to relativistic principles. The approach toward Jupiter's mysterious core persists in memory as an encounter with the ultimate unknowns of planetary science, where theoretical models provide abstract understanding of conditions that may create forms of matter that exist at the boundaries of physical possibility. The core region represents nature's most extreme laboratory for testing the limits of how matter can behave under gravitational compression. Gravitational effects that dominated the journey return as memories of forces that shaped every aspect of the experience, from the gentle initial attraction that began the fall to the crushing accelerations that compressed matter into exotic states near the planet's center. Gravity revealed itself as the fundamental force that creates and maintains planetary structure, while generating the extreme conditions necessary for exotic material phases. The limits of human imagination, encountered during exposure to conditions beyond any evolutionary preparation, remain as insights into the boundaries of consciousness itself. The journey revealed how human awareness must adapt when confronted with phenomena that exceed every parameter of familiar experience, requiring new forms of understanding that transcend direct sensory perception. Scientific understanding gained through the journey exists as abstract knowledge that bridges the gap between direct experience and theoretical comprehension of natural phenomena. The extreme conditions provided opportunities to observe physical processes that cannot be studied through any other means, creating insights into how matter and energy behave under circumstances that push the limits of natural law. The beauty discovered within Jupiter's violent interior persists as aesthetic memories that reveal how extreme physical processes can create patterns and phenomena of extraordinary elegance and complexity. The electromagnetic displays, circulation patterns, and structural organizations witnessed during the descent represented natural artistry operating on scales and under conditions that exist nowhere else in the solar system. Philosophical insights generated by encounter with the ultimate limits of natural processes remain as altered perspectives on the relationship between human consciousness and the cosmic environment that extends far beyond familiar terrestrial experience. The journey provided direct contact with forces and conditions that embody billions of years of cosmic evolution, operating under the most extreme circumstances. The memory of falling through Jupiter's interior becomes a permanent alteration of consciousness that carries awareness of natural phenomena operating at scales and intensities that transcend human experience while remaining subject to scientific investigation and abstract understanding. These memories represent knowledge gained through exposure to conditions that exist at the intersection of planetary science and fundamental physics. Floating in memory, the journey through Jupiter's interior stands as testament to the tremendous forces and exotic conditions that exist within planetary systems, where gravitational compression creates environments that challenge every assumption about the nature of matter and energy, while revealing the tremendous complexity and beauty that emerge from natural processes operating under extreme conditions that push the absolute limits of what physical reality can sustain. From a vast distance, Jupiter appears once again as a serene sphere of swirling clouds, its violent interior secrets hidden beneath atmospheric bands that flow with deceptive tranquility. The perspective of separation allows contemplation of the tremendous contrast between the planet's peaceful external appearance and the extreme conditions that dominate its interior regions, where matter exists under circumstances that challenge fundamental understanding of natural processes. The scale of what was experienced becomes more apparent when viewed from the context of Jupiter's position within the solar system. This single planet contains more mass than all other planets combined, yet it represents only a tiny fraction of the Sun's mass. The extreme conditions encountered within Jupiter's interior exist as natural consequences of gravitational compression operating on planetary scales that bridge the gap between terrestrial worlds and stellar environments. Earth, visible as a distant point of light, provides perspective on the tremendous differences between planetary environments that exist within the same solar system. The conditions that support life on Earth represent an extraordinary narrow range of temperature, pressure, and chemical composition compared to the vast parameter spaces where matter can exist under different gravitational and thermal conditions throughout the universe. The journey through Jupiter's interior revealed natural processes that operate continuously throughout the planet's structure, generating energy flows and material transformations that influence the entire Jovian system. These processes occur without external control or guidance, representing self-organizing systems that maintain complex structures over geological timescales through the interplay of gravitational, thermal, electromagnetic, and chemical forces. Technological implications of the extreme conditions witnessed within Jupiter suggest possibilities for future scientific investigations that could extend human understanding of fundamental physics through study of natural phenomena that cannot be replicated in terrestrial laboratories. The planet serves as a cosmic laboratory where extreme physics operates under stable conditions that persist for millions or billions of years. The electromagnetic emissions detected from Jupiter by radio telescopes on Earth represent direct communications from the planet's interior processes, carrying information about conditions and phenomena occurring thousands of kilometers below the visible surface. These radio signals provide the only direct evidence available for studying the exotic physics that governs matter under extreme compression and electromagnetic field conditions. Comparative planetology gains new meaning when Jupiter's interior conditions are considered alongside the wide range of planetary environments found throughout the solar system. Each planet represents a different experiment in how matter and energy interact under various combinations of mass, composition, and environmental conditions. Jupiter's extreme interior conditions represent one end of the spectrum of possible planetary environments. The persistence of Jupiter's internal structure over the 4.6 billion-year history of the solar system demonstrates the stability of physical processes operating under extreme conditions. The planet's ability to maintain complex circulation patterns, magnetic field generation, and atmospheric dynamics over geological timescales reveals the robust nature of natural systems that operate according to fundamental physical principles. Philosophical perspectives on the nature of reality undergo modification when extreme planetary interior conditions are considered as natural components of cosmic evolution. The exotic states of matter and energy found within Jupiter's interior exist as permanent features of the natural universe, representing forms of physical reality that operate according to principles that extend far beyond human direct experience. Scientific methodology faces challenges when investigating phenomena that exist beyond the reach of direct experimentation or detailed observation. Theoretical models and indirect measurements provide the only tools available for understanding conditions that cannot be replicated or studied through conventional laboratory techniques. Jupiter's interior represents the ultimate test case for theoretical physics applied to natural phenomena. The future of planetary exploration may include technological developments that allow more detailed investigation of planetary interior conditions through advanced remote sensing techniques, sophisticated computer modeling, or even robotic probes designed to survive extreme environments for brief periods. Such investigations could provide unprecedented insights into fundamental physics operating under natural conditions. Educational implications of understanding extreme planetary environments extend beyond simple knowledge acquisition to fundamental changes in perspective about the nature of physical reality. Awareness of conditions like those found within Jupiter's interior expands conceptual frameworks for understanding how matter and energy can behave under circumstances that exist throughout the universe, but remain beyond direct terrestrial experience. The beauty revealed within Jupiter's extreme interior conditions suggests that aesthetic appreciation can extend to natural phenomena that operate under circumstances completely divorced from human sensory experience. Mathematical elegance, physical symmetries, and complex organizational patterns create forms of beauty that transcend visual appearance and engage intellectual and emotional responses to the underlying order found in natural systems. Environmental awareness gains cosmic perspective when terrestrial conditions are viewed within the context of the vast range of planetary environments that exist throughout the universe. Earth's life-supporting conditions represent an extraordinary and perhaps rare combination of circumstances that permit the existence of complex chemistry and biological processes that require very specific ranges of temperature, pressure, and chemical composition. Looking back at Jupiter from the perspective gained through imaginary journey to its interior creates lasting appreciation for the tremendous complexity and beauty that exist within natural systems operating under extreme conditions. The planet embodies physical processes that span the range from familiar atmospheric dynamics to exotic states of matter that challenge the boundaries of current scientific understanding. The view from distance transforms Jupiter from a simple astronomical object into a cosmic laboratory, where fundamental forces create and maintain phenomena that represent some of the most extreme natural conditions found anywhere in the solar system, where gravitational compression generates environments that bridge the gap between planetary and stellar physics, where natural processes operating over billions of years create and sustain complexity that exceeds human technological capabilities by orders of magnitude. From this perspective of distance and reflection, Jupiter stands as a reminder of the vast range of natural phenomena that exist throughout the universe, where extreme conditions create opportunities for physical processes that generate complexity, beauty, and wonder that extend far beyond the familiar boundaries of terrestrial experience, inviting continued exploration and investigation of natural systems that embody the ultimate expression of cosmic forces operating under conditions that represent the limits of what natural processes can create and sustain. The journey through Jupiter's interior opens infinite questions about the nature of planetary systems throughout the universe and the tremendous range of conditions where matter and energy can create stable, complex structures. If one planet within our familiar solar system contains such extreme and exotic phenomena, what extraordinary conditions might exist within planetary systems orbiting other stars, where different formation histories and environmental factors could create even more unusual material states and physical processes? Technological possibilities emerge from understanding the extreme conditions that exist naturally within planetary interiors. The high-pressure chemistry witnessed within Jupiter's depths could inspire new materials, science approaches that create substances with properties impossible to achieve under terrestrial conditions. Electromagnetic phenomena operating at planetary scales might suggest new approaches to energy generation and storage that operate according to principles learned from studying natural extreme environments. Theoretical physics gains new testing grounds through detailed study of conditions that exist within planetary interiors, but cannot be replicated in terrestrial laboratories. Jupiter's interior provides a natural experiment in high-pressure physics, electromagnetic field theory, and extreme thermodynamics that operates continuously over geological timescales. The results of these natural experiments could guide theoretical developments that extend understanding of fundamental physical principles. Astrobiology expands its scope when considering the possibility that life might exist in forms adapted to conditions that seem impossibly extreme from terrestrial perspectives. The complex chemistry occurring within Jupiter, its high-pressure interior, creates organic compounds and energy sources that might support biological processes operating according to principles completely different from Earth-based life systems. Space exploration technologies could evolve to permit direct investigation of planetary interior conditions through robotic probes designed to survive extreme environments for sufficient time to gather unprecedented data about exotic material states and physical processes. Such technological developments would require advances in material science, energy storage, and communication systems that could operate under conditions that exceed current engineering capabilities. Fundamental physics faces the challenge of extending current theoretical frameworks to account for phenomena that exist under conditions approaching the limits of natural material stability. The exotic states of matter found within Jupiter's interior operate at the intersection of atomic physics, plasma physics, electromagnetic theory, and gravitational science, requiring integrated theoretical approaches that transcend traditional disciplinary boundaries. Philosophical implications of extreme planetary environments extend to fundamental questions about the nature of reality and the relationship between human consciousness and the vast range of natural phenomena that exist throughout the universe. The recognition that familiar terrestrial conditions represent only a tiny fraction of possible physical environments challenges anthropocentric perspectives on the nature of natural systems. Educational approaches to science education could benefit from incorporating awareness of extreme planetary environments as examples of how natural systems can create and maintain complexity under conditions that extend far beyond human direct experience. Understanding these extreme environments could inspire new approaches to scientific thinking that emphasize the tremendous range of natural phenomena and the power of theoretical frameworks to comprehend conditions beyond direct observation. Artistic and cultural expressions might find inspiration in the patterns, processes, and phenomena that exist within extreme planetary environments. The electromagnetic displays, circulation patterns, and structural organizations found within Jupiter's interior represent forms of natural artistry that operate on scales and under conditions that create aesthetic experiences, transcending visual appearance and engaging intellectual and emotional responses to underlying natural order.
Environmental perspectives gain cosmic context when terrestrial conditions are understood within the framework of planetary environment diversity found throughout the universe. Earth's life-supporting conditions appear increasingly precious and remarkable when compared to the vast range of extreme conditions that dominate most planetary environments, highlighting the extraordinary nature of conditions that permit complex biological processes.
Future scientific investigations could develop new approaches to studying natural phenomena that exist under conditions beyond the reach of direct experimentation. Advanced computer modeling, remote sensing technologies, and theoretical physics could combine to create comprehensive understanding of natural systems operating under extreme conditions that represent the limits of what natural processes can create and maintain. The potential for discovering similar extreme environments within other planetary systems opens possibilities for comparative studies that could reveal fundamental principles governing how matter and energy behave under extreme conditions throughout the universe. Each planetary system might represent unique experiments in extreme physics operating under different initial conditions and evolutionary histories. Technological spin-offs from understanding extreme planetary physics could lead to innovations in energy generation, materials science, electromagnetic engineering, and space exploration technologies that operate according to principles learned from studying natural systems that create and maintain complex organization under conditions that exceed current human technological capabilities. Scientific methodology could evolve to address the challenges of investigating phenomena that exist beyond the reach of direct observation or experimental replication. New approaches to theoretical modeling, data analysis, and scientific inference could emerge from the necessity of understanding natural systems that operate under conditions where conventional experimental approaches become impossible. The recognition that extreme conditions create opportunities for natural processes that generate extraordinary complexity and beauty suggests that the universe contains vast realms of phenomena that await discovery and investigation. Each extreme environment represents a potential source of new scientific understanding and technological inspiration that could transform human capabilities and perspectives. Jupiter's interior conditions represent only one example of the extreme environments that exist throughout the universe, where different combinations of mass, composition, and evolutionary history create planetary systems with interior conditions that might exceed even Jupiter's extreme parameters. The possibilities for discovering new forms of matter, energy, and natural organization appear limitless when considered within the context of cosmic evolution, operating over billions of years under conditions that span the full range of possible physical parameters. The endless possibilities suggested by extreme planetary environments invite continued exploration and investigation of natural systems that embody the ultimate expression of cosmic forces, where gravitational compression, electromagnetic phenomena, thermal processes, and chemical reactions combine to create complexity that transcends human imagination, while remaining subject to scientific investigation and theoretical understanding, opening infinite opportunities for expanding knowledge of the natural universe and developing technologies that harness natural principles operating under conditions that represent the limits of what physical reality can sustain and maintain. If this journey through Jupiter's hidden depths has stirred your curiosity about the cosmos and the extreme conditions that shape our universe, perhaps you'd find value in exploring more mysteries that exist beyond our everyday experience. The universe holds countless secrets waiting to be discovered, each one offering new perspectives on the remarkable forces that govern reality itself.